this is capital. This one. Twende huko. Oh, sorry. Ini ya. Sio hiyo. Sio yangu. Oh, you can speak. Speaker. Hey, hey. Okay.
Thank you, colleagues. We have come to our second day of our conference. We'll call the session to order. I request that we all stand up and sing the national anthem, one stanza, and then the East African national anthem, one stanza. So let's all rise and sing the national anthem. We'll start with the national anthem, the first stanza. Mungu nguvu yetu, ilete baraka kwetu, akiwe ngao na mlinzi, na tukae na undugu, amani na uhuru, raha tupate na ustawi. We go to the East Africa. Ewe Mungu tuomba utulie, Jumuiya ya Afrika Mashariki, tuwezeshe kuishi kwa amani, tumize malengo yetu, jumuiya yote sote tuilinde, tuwajibike, tuimarike, umoja wetu ni nguzo yetu, idumu jumuiya yetu. Thank you. Now I'll request Dr. Daniel Orango to lead us with a word of prayer.
Okay, let's bow down our heads for a word of prayer. Our Heavenly Father, in the name of Jesus Christ, this morning we come in your presence with thanksgiving. Thank you, Lord, for this is yet another day that you have given us in this Chemical Science Conference, University of Eldoret. We thank you for giving us favor and a new day, dear Lord Jesus. We commit all the presentations, those who will be presenting, those who will be attending from far and wide. We pray that, Lord, you will give us victory in each presentation. Receive all the glory and honor forevermore. In Jesus' name we pray. Amen.
Thank you. We can sit. So I think let's do some bit of housekeeping and announcement. So today's session is special. It is being streamed live, and we request that we kindly keep time. So in terms of the program for today we are going to start with the parallel sessions. They are going to run from 8:30 or immediately after this session up to around 10:30. And then after that, we are going to have a short health break from 10:30 to 10:55, after which we'll now have the keynote speakers speaking. So this session will run from 11, and it will go all the way to 12:30. So today is a bit different. We'll start with the parallel sessions. Up to 10:30, we have a health break to from 10:30 to 10:55. Then we'll come to the main conference hall for the keynote speakers, and then I think after that we'll give you the direction. So in terms of the rooms, for the parallel sessions, you can join using the other two venues, but for the keynote speakers, you'll join you'll join in the main conference. That's where we are going to have the two sessions. So maybe at this particular point, I'll just request that we break into the various groups, and the people people in charge of those groups, kindly ensure that we observe time so that by 11 we should all join the main conference room for the address by the keynote speakers. Thank you very much. So we can go to our breakup rooms for the parallel sessions, unless maybe okay, I think it's okay. Thank you.
Recently, there has been a 2% decrease in productivity, and this decrease has been attributed to crop protection practices such as weed, insect pest, and disease management. Weeds have been estimated to cause a decrease of 45%. And therefore, weed management is a very important cultural practice to ensure that farmers get maximum yield. Weed management has been done with the usual practices such as hand weeding, and mulching is a very important component in crop production, but very limited studies have been done on the effectiveness of mulch as a weed management strategy. And therefore, my experiment was focusing on evaluating the growth and yield of French beans as influenced by mulch, and identifying the best mulch practice for weed management to increase yields. My experiment was carried out in Trans Nzoia County, Kitale, Calro Food Crops Research Institute.
Excuse me, Carazon.
I had the experiment.
Excuse me, Carazon.
Yes.
Please, can you just display
Yes.
your slides better, because we can't see them clearly, your slides. Can you put maybe slideshow or something, because we cannot be seen clearly.
Let me try and adjust that.
Or can we do it from this end, so that we can just project them?
It's okay. It's okay. Let me just stop sharing.
Okay, fine, thanks. So there you are. You can now tell us where to go to, and then you can simply go to that slide.
I was in slide 9.
9, okay.
Yes. Can I now continue?
Yes, please.
Yes. So when I laid my experiment, I was collecting data 4, 5, 6, and 7 weeks after emergence. I chose 3 plants, randomly tagged them for data collection. The data that I collected mainly was on plant height, number of branches per plant, and the number of leaves per plant. And the yield parameters included the number of pods per plant and the total weight. My data analysis, I did analysis of variance using GenStat version 12.5 and separated the means using Duncan multiple range test. Next slide, please. From the results, mulching had a significant effect on the weed density in all the plots. Plots that had the mulch, the grass and the black polythene mulch had a significantly lower weed density. And this can be attributed to the fact that mulching reduces emergence and germination of weed seeds and suppresses weeds that have already grown, as it creates a barrier, keeping the weeds in control. Also, black mulch is considered to be more effective for weed control as it prevents the penetration of light to the soils. A similar experiment was carried out by Osom in 2001, and from his observations, there was a significant difference in weed control between mulch and non-mulch plots of eggplants. Next slide. Mulching also had a significant effect on the growth and yield of French beans. Plant height, number of branches, number of leaves, number of pods, and weight of pods were all significantly affected by the mulch. Plants under black polythene and grass mulch had a higher plant height, had more number of leaves and more number of branches as compared to those which were hand weeded and the control which was not weeded at all. Black polythene mulch had a significant high number and weight of pods, followed by grass mulch and hand weeding, and finally, control had the lowest. The high significant difference in French bean yields between the mulch and the non-mulch plots can be attributed to the fact that mulching also improve crop stands and increase yields as they provide favorable microclimate for optimum plant growth. Mulching also improves the soil properties by moderating temperatures, reducing rate of evaporation, runoff, and soil erosion. Next slide, please. So from my experiment, I concluded that mulching influenced the growth and yield of French beans as well as the weed density. Black polythene mulch performed better and produced highest yields, while the non-weeded plots produced the lowest. Mulching also influenced weed density and can also be used to control weeds, although the effectiveness varied. That's why the black polythene mulch performed better than the grass mulch. So not all mulch will control weeds or will improve productivity the same way. They all vary. Black polythene mulch performed better than grass and hard weeding and is therefore the most recommended mulch for weed control. Thank you. That is the end of my presentation.
Okay, thank you very much, Carozon, for that presentation. Thank you again for keeping time because we have taken quite some short time. Now I invite some questions or comments concerning Carozon's presentation. Any comments, any questions? Now, if as people are still waiting for, as I'm still waiting for other questions, I think I can ask you one.
Yes.
it doesn't seem to be new knowledge about mulching. I think we know what mulching does from time immemorial. Now,
Yes.
why you comparing the effect of black polythene and grass, or you're just doing mulching in general?
Let me answer that. Generally, mulching is not a new practice, but most of us use mulch not for weed management. Mostly we use mulch so that we create a microclimate for plants. So I was trying to compare black polythene mulch and grass. Grass is the mostly widely used type of mulch. But I was not looking at how they create the microclimate, but rather how they affect weeds and productivity.
Thank you very much. Then I think it should come out clearly that what you are doing is a comparison of the two mulching agents.
Oh, okay, thank you.
Okay, another comments, another question concerning Carlson's presentation? We are still waiting for comments, questions. Those of us who have been following the presentation. Okay, we don't seem to have any further questions about Carlson's presentation. So thank you so much, Carlson, for your presentation, and wish you well as you continue
Thank
your
you.
work.
Thank you so much, Chair.
Now, so I think next in line is Frank. Frank, can you hear me?
Yes, I can hear you.
Please, can you make your presentation, please? Proceed.
Okay. Can you hear me on the other side?
Yes, we can hear you.
Okay, my presentation is on assessment of water and habitat quality status of an urban headwater stream.
Sorry, Frank, we cannot see your slides. Can you project the slides? Oh, let's share the slides from this end, and then you can present. Just a minute.
Okay, thank you. I can see my slides there.
Just a moment. Fine.
Yeah.
I think you can now go on.
Okay. I was doing an assessment of water and habitat quality status of an urban headwater stream, and the case study was of River Sosiani. My name is Opanja Franklin Zamorano, registration number FIS 014/17, and I was being supervised by Dr. Frank Masese and Mr. Augustine Sitati. Next slide, please. Okay, introduction. It is clear that water quality of pristine rivers is being influenced by geochemical factors and the best location of the river. Reduction in water quality will in turn result to reduced ecosystem health and services, which will hamper human use and also hinder sustainable development. A major concern of management is the excessive loading of organic matter and nutrients into the surface water resources. The factors include spatial expansion arising from high rural-urban migration rates, which has made the town, which in this case is Eldoret town, one of the fastest growing town in the country. River Sosiani flows through the Uasin Gishu County, and it is the main river basin of the country. A complex of parallel streams that joins from north and easternward meet the river at River Nzoia in Kakamega County and eventually enters into Lake Victoria. Another slide. The lotic system, which is the flowing water, are influenced by anthropogenic pollution and their effects can be felt miles away downstream. In Eastern Africa, the population growth is increasing at an alarming rate, and this leads to accelerated deforestation, urbanization, industrial expansion, and commercial irrigation or agricultural activities threatening freshwater bodies. River Sosiani catchment has witnessed rapid population growth rates in the last 3 decades. Eldoret, being the major town in the catchment, has experienced a population increase of 200%. This one can be translated into 300,000 people growth in the last 3 decades, as per the Kenya National Bureau of Statistics 2019 data. Okay, the justification of the study. The population pressure and increase of land use change is expected to severely impact heavily on the water flowing in the rivers and hence the need to study water and habitat quality of the river. It has been suggested that agricultural, domestic, soil erosion, and wastewater contributes to production of heavy metals when discharged into the river. And this study will enable the county government of Uasin Gishu to control water pollution of the River Sosiani. In my study objectives, the general objective was to assess the status of water and habitat quality of River Sosiani. And my first specific objective was to determine the spatial variation of water physiochemical variables and nutrients concentration along River Sosiani. The second objective was to assess spatial variation of in-stream and riparian habitat quality variables along the River Sosiani. And my third objective was to compare the obtained water quality levels along the river against those ones that are recommended by the WHO and the NEMA standards. My fourth objective was to develop a water quality index for River Sosiani. Next slide, please. Materials and methods. As you can see from the map there, my study sites were 5. I began from Two Rivers Dam, which is the lowest in the map, but actually that one was my first study site. It was upstream. I went to Nairobi Bridge downstream, and I was giving an interval of 2 to 3 kilometers to enhance the effects of the pollution in the river downstream. My third study sampling area was Sokoni, which is within the CBD, and Mailinne, which is at the outskirts of the CBD, and downstream Turbo. As you can see, they are marked there on the map. Next slide. Next, please. Okay, study design. 5 sites were selected along River Sosiani, as you have seen from the map there. And the plates there are just representing the study sample collection sites, whereby the first slide where the first plate where the water is clean, that's my first sample collection site. Where I'm standing there is Nairobi, below Nairobi Bridge. You can share with them the plates. Yeah, okay. Where I'm standing below the bridge is below Nairobi Bridge, where there is litter hanging on the roots of the root mats of the trees. That's Sokoni. And where I'm squatting on a stone collecting water, that's Mailinne. Next slide, please. Sample collection. Measure of the physiochemical variables such as water ambient temperature, DO, pH, total dissolved substance, and salinity were measured in situ using YSI 556 MPS portable multi-probe during the wet season. The riparian and in-stream habitat assessment was also done at each site qualitatively to determine habitat quality and diversity using the Qualitative Habitat Evaluation Index in bracket QHEI adopted from the ranking system in 1995 and modified from the Lake Victoria Basin. Nutrients analysis in the laboratory was done in the university laboratory after the water samples were filtered through 0.45 glass fiber filters papers for determining the concentration of the nitrates, nitrites, ammonia, soluble and soluble reactive phosphorus by using the standard spectrophotometric method described in the APH A 1998. Next slide, please. During my data analysis, I used one-way ANOVA to test for the significant differences in water and habitat quality variables across the sites. I used the Turkey post hoc test, whereby I used this test to establish the differences among the sites. Water quality index was used to assess the status of River Sosiani. Next slide, please. Results. As you can see from the table there, I have the variables, and from the sides, you can see temperature was varying from Two Rivers Dam, Nairobi Bridge, Sokoni, Mailine, down there. And when I performed the ANOVA, you can see the values were significant. Only nitrates was not significant together with the soluble reactive phosphorus. Next slide, please. From the habitat variables, as you can see, they were varying, whereby from the first sampling site, it was okay. Going downstream, things began to change due to the influence of the human activities along the riparian, which modified the habitat and also degraded it downwards. And as you can see from the fourth sampling point, the river began to regain its natural habitat downstream to Turbo. Another slide, please. The total habitat quality scores variation across the 5 sites were depicted from the bar graph below. Two Rivers Dam, it was okay. Nairobi Bridge, it began now to have a lower habitat score of from 61 to 59. Sokoni was the poorest because of the dense anthropogenic impacts that were degrading the sampling site, whereby it has the least score of 42. Mailine, the river has now begun regaining its natural habitat. It goes back to 54. And then Turbo had minimal anthropogenic disturbance. It was excellent to 67. Next slide, please. The water quality index from my site, as you can see, from site 1, it had 19.67, depicting that the water type was excellent for human use. Site 2, it now began to change. The anthropogenic impacts were now visible. As you can see from in the Two Rivers Dam, there are no anthropogenic impacts. They were only farming, and they were done 100 meters from the riparian. Nairobi Bridge, there is a factory there which I think releases the effluents into the river, whereby now it was affecting the score to be 27.48. The higher the score, the poor the water type quality. So as you can see from Nairobi Bridge, the water type was good for human use. And then Sokoni, which had a dense anthropogenic impact, had a higher score of 89.29, depicting that the water is not good for human consumption, since the score was poor. After the CBD, you go to Huruma, Mailine, whereby now the activities have gone down, the water quality regains its status, it begins to be good onwards, until you see from Turbo there, it had a quality of 23.59, being that it is excellent. And the entire river, from the mean assessment of the entire river, you can get that the entire river water is good for human use. Another slide, please. The water quality parameters that I got, I compare them together with the WHO 2011 recommendations. And as you can see, the temperature, there is no recommendation for NEMA and WHO. And mine, I got it to be 23.03 degrees. The pH to be 6.5 to 7.5. WHO recommends it to be 6.5 to 8.7, and mine I got it to be 7.77, which means that the pH of River Sosiani is within the recommended range. The total dissolved oxygen, as you can see, the recommended maximum is 1,000 milligrams per liter, and mine was 50.95 milligrams per liter. It met the standards. The conductivity, as you can see there, also mine was the lowest compared to the recommended ones of 500, between 500 to 5,000, which means my samples conformed to the NEMA and WHO standards. As you can see down there, until the turbidity also, my portable YSI did not have an option of measuring the turbidity. And the dissolved metals, as you can see there, I wasn't dealing with the dissolved metals like copper and manganese. I was dealing with the dissolved nutrients, sulfates, phosphates, nitrates, and nitrites. As you can see from the...
Frank, you can just summarize because of
yes,
time.
yes.
You can just go a bit faster.
Okay.
Fine.
Yes.
Okay.
Next slide, please. From the conclusion, I concluded that most water quality physiochemical variables in the River Sosiani was greatly affected by the anthropogenic activities along the riparian. And in the addition to that, the prevailing season, whereby I did the sampling during the wet season, it exposed out that the impacts of the land use change on water and habitat quality variables also were being influenced by the wet season, whereby the nutrients were washed from the riparian into the river. And also the study found out that agricultural activities on the riparian along the river enrich the water, especially through surface runoff when it rains. And I recommended that awareness creation and sensitization on the importance of water. I recommended regular river cleaning, afforestation, and also conducting further studies on River Sosiani to be able to come out with measures to curb. Thank you.
Okay, thank you very much, Frank, for that very good presentation.
Yeah.
And I will invite comments and questions concerning Frank's presentation. Yes, Prof. Luther.
Thank you, Dr. Wedu, the chair. Thank you, Frank, for the presentation. I just have two questions and maybe a comment. Number one, I missed out on the part. I don't know when this study was done because I was expecting, because of the post-COVID effect of using soaps and detergents for cleaning, I expected us to detect some phosphates and nitrates in the water, even sulfates, but I was seeing for your case, we didn't get anything. And then number two, did you try to compare the results with what other people have done? Because I know for River Society, there's a lot of work which has been done on the same. And then I think the maybe tell us what do you think could be the cause of high conductivity in the water samples that we collected? Thank you.
Okay, thank you, Prof, for the questions. I'll respond to the first question, whereby you are asking when the study was conducted. The study was conducted in July to August 2021, whereby during that period, Uasin was experiencing a little bit of rainfall, and this rainfall was responsible for surface runoff, whereby the activities being done on the riparian were being depicted in water through the 4 nutrients: nitrate, nitrites, phosphorus, and also potassium, soluble reactive potassium. And you asked whether the soluble reactive potassium was there in my results. In the table there, it is in the last column. You can see I found out the soluble reactive potassium from the 5 sampling sites, and this was also as from different from the natural fertilizers, because it was the COVID season, and soap contains potassium. It was also evident because a study sampling point like Sokoni, where it was in the heart of the CBD, people were doing the washing and it was draining into the river, making it to have the highest point with. And when you asked about the conductivity, I'm sorry, my YSI probe was faulty. So it
Recording in progress. Can you hear me? Sorry for that interruption. Frank, if you can hear me.
Kipsaina Dam as compared to Ziwa Dam, where there was a lot of activities. On fish distribution across the dams, Asururiet had Enteromias yongei, E. paludinosis, Cheposom had Sarcops, Elecrines, Allegrine Dam had in Enteromias numeri, Kipsaina had more species, that is E. apleurogramma, numeri, and paludinosis. Kerita had numeri, Keses had apleurogramma, Usalama, in Usalama Dam, we sampled Sarcops and numeri. In Ziwa, we sampled numeri and paludinosis. We realized that Enteromias numeri was the most widespread species of this genus Enteromias, with actually Kipsaina Dam having several species. And as we had seen the water quality of Kipsaina, this could actually be attributed to the good water quality in the dam, as we realized that the dam had very minimal human activities as compared to the other dams that we had sampled. On water quality, dissolved oxygen was actually correlated to Sarcops, salinity, conductivity, and nitrites were negatively correlated. Turbidity was positively correlated to numeri and negatively correlated to yongei. So we realized that the change in water quality and environmental variables affected the fish distribution, with actually classical cases of Kipsaina Dam having good quality. And because of that good quality of water, we realized that the species were highly distributed as compared to Ziwa Dam, which had poor, low water quality, and therefore the species of Enteromias were few there, because we attributed these maybe to the water quality and a lot of human activities and fishing around Ziwa Dam. So community diversity in index is shown there. And we can see the collected fish samples, that we kept in the lab for further studies of morphometrics and other studies. So from this study, we realized that water quality actually affects distribution of these Enteromias species, with numeri being the most abundant species, and the dam that had good water quality being the Kipsaina Dam, having a variety, a higher number of species of Enteromias. So there was actually a relationship of water quality with the distribution of fish species, that is Enteromias. So as per our study, we actually realized that there is a relationship really of water quality. So the degraded dams, the dams with a lot of human activities had and a lot of fishing had actually few species of Enteromias. So much study is to be done to actually sensitize the community on how the dams are to be taken care of to enhance conservation of these. Those are the samples as presented on the screens. Those are the samples of fish that we preserved in ethanol, and they are in the lab. And actually, the county government of Uasin Gishu is doing some work on these dams. So I think with this, we will be able to give them a feedback on the effect of farming activities and a lot of fishing in the dams. Those are us sampling and weighing the Enteromias. And from this, we were able to realize that water quality actually and human activities affects the species of fish, not only Enteromias. So from our study, we acknowledge God, the university annual research grant, the National Research Fund, the family and colleagues, the fisher community around the dams, the University of Eldoret, Thank you for listening, and thank you for being able to wait for me as I had that problem. Thank you so much for the presentation, and may God bless you.
Thank you. Thank you for distribution and composition, finding that there is a direct correlation between water quality and fish distribution. I now open for one or two questions or comments on this very interesting talk. So anybody who has something to say, this is the time. Thank you. So thank you, Jepleting. It seems as if everyone is satisfied with your very good work. And thank you. And again, thank you.
Thank you so much, and God bless you.
Asante. Now, next on this on the talk is Kangol Wesley Very Moi, and he will present this. And he will be presenting to us a talk on investigation of Myalua shrub yeast from figure millet for production of cheap and efficient bioethanol in Kenya. Can you hear me, Kangol? Kangol, can you hear me? Kangol, can you hear me? Kangol? Kangol, can you hear me? Hello, can you hear me, Kangol? I can see you have unmuted yourself. Can you say something so that we hear? Okay, please let us know when you are ready. I will go to the next speaker for today. That is Dr. Sifora Wanyambu, and she'll be giving us a talk on in vitro bioaccessibility of vitamin B series from thermally processed leafy African vegetables. And I welcome her to give us this talk. Dr. Sifora.
Thank you, Chair. Thank you, Chair. My name is Awunyambu Zipora Mora, presenting my research findings, which have already been published, entitled In Vitro Bioaccessibility of the Vitamin B Series from Thermally Processed Leafy African Indigenous Vegetables. There are my co-authors. Then micronutrient deficiency is rampant mainly in developing countries. The WHO has reported that there is an increase in malnutrition in Africa mainly. Morbidity and mortality currently stands at 45% and 10% respectively. This has led to a reduction in productivity and even economic growth because of the effects of the diseases caused by the deficiency of these nutrients. For example, lack of vitamin B5 results in depression, which leads in reduction in the thinking. So which has resulted in a reduction of human production and even economic growth. For example, lack of vitamin B5 results in depression. This leads to someone not being able to do his work promptly. A lot of work, stress, fear, not properly thinking, so it leads to low production in all aspects. The source of these vitamins can either be from animal products or plant products. Animal products are normally expensive, while on the other side, plant products are known to be inexpensive and locally available. Reports have been, there are reports that the production, the plant products have nutrients which are able to meet the recommended dietary allowances as set by the WHO. An example is that of Nawiri et al. 2013 and that of So these vegetables can be consumed when they are boiled, fried, dried, or even prepared in various recipes. It is one thing to know the quantity or the amount of the vitamins in the vegetables, and it is another one to know how much of that vitamins is able to be absorbed to the system for metabolic purposes. So the processing of vegetables mainly improves the availability of these vitamins and nutrients. One other thing to note is that the presence of fiber in the vegetables reduces the bioaccessibility of these nutrients in the body. These studies were reported by Veda et al. So now, what is bioaccessibility? Bioaccessibility refers to the quantity of nutrients in food that is ingested that is potentially available for absorption. A number of factors affect bioaccessibility, the main one being the food matrix. Others are fat content, temperature, and digestibility, among others. How is this bioaccessibility determined? Two ways of determining bioaccessibility. One is through in vivo, and another one is through in vitro. The in vitro one is preferred because it is accurate, valid, and producible. It has no ethical issues, and the time and money saving aspect. It is also detailed, sensitive, and the measurements are accurate. There is a table showing the recommended dietary allowances of the vitamin B series. Then what is the problem? There is malnutrition growing mainly in developing countries, yet we have these inexpensive sources of these vitamins. The leafy African indigenous vegetables are an example of that. These vegetables are inexpensive, locally available, and they can be consumed both fresh and cooked. They can even be dried to help address the post-harvest loss. Then there is this need of knowing how much of these nutrients is bioavailable or bioaccessible. And this brings us to the necessity of simulated studies to address the bioaccessibility of the vitamin B series in leafy African indigenous vegetables. To the scope now, 5 leafy African indigenous vegetables were considered. Among the vitamins, the B series were considered, that is B1, B2, B3, B5, B6, and B9. Among the methods of preparing the vegetables, the household recipes were considered, and in the drying, only oven drying was considered in this study. What were the limitations? The seasonality was not considered. The source, variety, and age of the vegetables were not considered also. To the hypothesis now, processing vegetables does not affect does not significantly affect bioaccessibility of vitamin B series from selected leafy African indigenous vegetables. What is the general objective? It was to investigate the effect of processing of bioaccessible levels of the vitamin B series in selected leafy African indigenous vegetables. The specific objectives were to determine the levels of vitamin B series in fresh and processed spider plants, cowpeas, amaranth, vine spinach, and pumpkin leaves. The second specific objective was to determine bioaccessibility of vitamin B series from fresh and processed spider plants, cowpeas, amaranth, vine spinach, and pumpkin leaves. The methodology, that was the research design. Samples were collected, processed, levels of vitamin B analyzed, bioaccessibility done when they were fresh and also done when processed, then data analysis was done. That is an overview of the research. To the main method now, the vegetables were analyzed when fresh. The extraction of vitamin B series was done when the vegetables were fresh. It was also done when they were boiled, and also done when they were boiled and fried, and another sample was when they were dried in the oven. After extraction, they were analyzed using HPLC, and then data analysis done using ANOVA. How were the levels of bioaccessible vitamin B series done? This was done using a digestion, which was done in 2 steps. The first phase was gastric and the second was intestinal. Both phases involved digestion of the vegetables using the enzymes indicated there, and the parameters or the conditions were set as per the chart. Then gastric phase took 2 hours, while intestinal phase also took 2 hours. So all the fresh were digested, the boiled, and the all boiled and fried. The product of the same was centrifuged from where we were able to get the sample that was analyzed using HPLC. The data, once again, was analyzed using ANOVA. To the results now. Table 1 shows the mean levels of vitamin B series in the fresh and processed spider plants. So the ones in purple are showing the highest levels of vitamin B1 in each of the vegetables and in each of the treatments done to the vegetables. The first row was the fresh, the second row, the boiled, the third one, fried. They were boiled first, then fried, and the last one were the dried. So the table shows what the levels were. The highest ones were those indicated in purple. The lowest ones are those indicated in red. The same trend is used to demonstrate the levels of these vitamins B series in all the vegetables. This is for spider plants. The next one is for cowpeas. Next, we have one for amaranth. Next, we have one for vine spinach. And finally, on the vegetables, that is one for pumpkin leaves. Then how were the percentages bioaccessibility determined? So from the same, the percentage bioaccessibility of each of the vitamins were determined using the levels that were initially in the vegetables and those that were determined after digestion. Both sides of the digestion were considered. We have the part that was digested and the liquid part of after digestion and the solid that remained after digestion. So both were checked and we are able to get the percentage bioaccessibility by getting that which was able to get to be bioaccessible before digestion and that which was digested before digestion, and then the percentage was obtained by multiplying the same by 100. And the table here demonstrates or shows the percentage bioaccessibilities of the vitamin B1 in each of the vegetables. The first one is spider plant, the next one cowpeas, amaranth, vine spinach, and pumpkin leaves. This same was used to show the percentage bioaccessibilities of all the vitamins. So this is vitamin B1. The next one shows the same for vitamin B2. The third figure shows for vitamin B3. For vitamin B4 is figure 4. Vitamin B5, sorry, is for figure 4. And then figure 6, vitamin B6. We have the last figure, vitamin B9. What is the significance of the study? The findings from this study provide information on nutritional values or the nutritional guidance in order to fight malnutrition or deficiencies of the diseases related to vitamin B series. It will further help in promoting the consumption of the vegetables. To the conclusions now, it was concluded that both fresh and processed vegetables, that is the spider plant, cowpeas, amaranth, vine spinach, and pumpkin leaves, contain significant levels of vitamin B series. It was also noted that the levels are raised a bit with mild treatment or processing. Two, it was concluded that the levels of vitamin B series in the vegetables were sufficient and bioaccessible. Recommendations from the study is that the consumption of these fresh and processed vegetables will help to address food security and malnutrition. For further studies, in vivo bioaccessibility studies of vitamin B series from fresh and processed leafy African indigenous vegetables, and also both in vitro and in vivo bioaccessibility for other macro and micronutrients. These are some of the references. Then my acknowledgements. Thank you very much.
Thank you. That's very interesting talk on talk of vegetables and bioaccessibility, mainly on vitamin B. Now, I would like to open this for a few questions and any comments. And first, I would like Dr. Nyam to elaborate on why the accessibility is improved by heating. Thank you.
So on heating, there is this aspect of food matrix. These nutrients are always enclosed in a food matrix. When vegetables are heated, the food matrix is opened up and it releases the nutrients in the same.
Thank you. And anybody else now can raise a question or have a comment. Okay, I don't see any hand which is raised. And once again, I thank Dr. Sephora for that very interesting talk. Okay. On the chat, there is a question or a comment from Dr. Murray. He's saying she needs some brief description on the results. Yes.
So the results were tabulated in tables. Each of the vegetables was represented in a table. So table 1, for example, is that of the levels of the vitamin B1 to B9 in spider plants. We have the row of vitamins. Then the next row is that of fresh vegetables. The second row is that of the boiled vegetables. The third row is that of the fried vegetables. I explained that the fried vegetables were first boiled, then they were fried, the way it is normally done. Then the rest, the row that is coming down there is that of the dried vegetables. So the levels of each of the vitamins are given. The first column gives the vegetables. The second column is the levels of vitamin B1, then the levels of vitamin B2, B3, B5, B6, and B9. The colors which are put there on the levels, for each vitamin, the highest levels are those in purple. For each vitamins, the highest are those in purple and the lowest are those in red. Where we have ND, it is where they were not detected. For some few cases, they were not detected. So for the spider plants, this is a summary of the levels showing the highest and the lowest levels. And this is done for all the vegetables. This is spider plants. The same is done for all the other vegetables, showing where the levels of the vitamins were highest and where they were lowest. So a comparison was done later, showing how the percentage bioaccessibility of each of the vitamins in each of the vegetables and for each treatment. And that is what was represented in graphs, which are just below these results. I don't know whether, Dr. you are answered.
Okay, I think you have attempted to answer, and I think Dr. is okay, and as you can see, she has said fine. Okay, thank you. I don't see any other raised hand, and once again, I thank you, Dr. Sisora. And now I would like to call upon Kangol to give a presentation.
Okay. Hello.
Hello, I can hear you.
Oh, you can hear me?
Yes.
Okay. Okay. Thank you. I'm sorry for the network issues.
Yes.
Yeah. So my presentation is on investigation of novel plants, Nairua shrub, which by botanical name is Nairua sapodata, for cheap and efficient bioethanol production in Kenya. So this is a paper which has been published. So so already, for those who have not got my name, I'm Gagor Rimoy Wesley. Now I've already given you the topic. This is a paper which has been presented and published. So introduction, bioethanol is an attractive source of energy when compared to fossil fuel. It is renewable and environmentally friendly due to its low toxicity and biodegradability. So because bioethanol is biodegradable and less toxic, the first generation bioethanol, you realize that it is expensive due to high cost of food crops, and also it causes a problem of food insecurity. Statement of the problem. Currently in Kenya, bioethanol is being produced from molasses, which is derived from sugarcane and also from other food crops such as cassava, sorghum, and maize. As a result, the cost of bioethanol production in the current manner is quite high and also poses a threat to food security. Also realized is justification. There is a need for to seek alternative ways to reduce the cost of bioethanol production. Non-food crops such as Nairua sapodata can potentially provide alternative sources to replace food crops like sorghum, cassava, maize, and sugarcane molasses. So the objectives of this study, the overall objective is to investigate a novel starchy plant for production of cheap bioethanol or to produce bioethanol which is cheap by using a starchy or plants with a lot of starch. To compare ethanol, the specific objective is to compare ethanol productivity from fermented Nairua sapodata, cassava, sorghum, maize, and maize flour and sugarcane molasses. So the methods and sample collection and identification. The Marua Shrub was collected from Kabilula village, a mining division, Mogotio County in Baringo County. The reason is because the plant was available in that area in its natural habitat. Also, the other plants which were collected was cassava, maize, sorghum, finger millets. They were also randomly collected from farmers, and the plants were identified by botanists from University of Eldoret. Sugarcane molasses was purchased at an agrovet in Eldoret town, and 100 grams of standard yeast, that is Saccharomyces cerevisiae, was applied by agrochemicals company of Kenya at Moroni. Now, the other method, fermentation analysis, samples were weighed about 20 grams each, autoclaved, and enzyme amylase, alpha amylase, and yeast were added to ferment this, and the samples were fermented. After 48 hours of fermentation, samples were distilled. They were dichromate oxidized and analyzed at 595 nanometers using UV visible spectrophotometer. Okay. Yeah. Data analysis and presentation. Descriptive statistics, where the means and standard deviations were used to summarize ethanol concentration. One-way analysis of variance ANOVA was used to determine significant difference in ethanol concentration from Maerwa shrub, cassava, sorghum, maize, sugarcane, molasses. Statgraphics Centurion 16 was used to carry out the statistical analysis. LST Fisher least significant difference was used. Now, results and discussion. Now, from the results, the green color of standard ethanol and samples in potassium dichromate confirms the presence of ethanol in the distillate as a qualitative analysis. Calibration curve was constructed basing on the results obtained by determining the absorbance of the standard solution prepared. Dichromate solution was used as a blank. A graph was plotted obtaining a straight line where R was 0.9983. There was a strong correlation between absorbance and ethanol concentration. Concentration of samples was obtained by substituting X with absorbance. The ethanol concentration in grams per liter were obtained by converting percentage volume per volume in 100 mils to a liter, which is 1,000 mils, then multiplied by density of ethanol, 0.789 grams per mil. The results were represented using bar graphs as shown in the figure below. So in that figure, you have yeast, the results from yeast 1, yeast 2, and yeast 3. And you can see from Maerwa shrub is you ferment using the 3 types of yeast.
Hello, we can't hear you. Can you hear us? Hello? Hello? Kandol? Hayuko. Now,
Sorry for the loss of network.
Oh,
Sorry for
you're
the
back.
yeah. Sorry, I
Can
lost
you
the network.
summarize that? Yes, let us go back to where you had reached, and then
Yeah.
you
Sorry
can,
for the loss of network.
you can conclude. Yes, you
Yeah,
were
yeah.
there when we lost you.
I've got beyond there.
Okay, yes.
10.
Please,
It's like 10.
you can wind up.
10, eh?
Yes, okay, continue.
Yeah, 10. Okay. So I was in going to maize. So for the maize, in the maize, you have 50.7, you have 66.7, and you have 56.3. That is across all the yeast. And then we have for sugarcane molasses, you have 49.7, you have 50.0, you have 56.6. And then, so that is the figure to summarize the results. So note that the values presented means are the means of duplicate experiments which were determined for significant difference at p 0.05. So mean ethanol concentration grams per liter and the productivity was grams per liter divided by the 48 hours or per hour, you get per hour for plants. So for plants across all yeasts were comparable. P-value is equals to 0.423 and F ratio is 1.03. So there was no significant difference across all the yeasts. So Marwa syrup should be used in production of cheap bioethanol because of producing high ethanol concentration and productivity when fermented, specifically when yeast 2 was used. This results as insignificant difference compared to the concentration from maize, cassava, and sorghum. So these crops are food sources. Therefore, the cost of production for bioethanol is higher than the cost of using bioenergy, meaning that the maize, sorghum, and cassava, when used for production of bioethanol, it will cause it to be expensive. Based on the that is conclusion and recommendation, based on the findings, Myra Shira showed ethanol productivity that is comparable to that of cassava, sorghum, sugarcane, molasses, and maize. Therefore, the plant should be used to substitute these food crops. Ethanol produced from Myra Shira will enhance food security, hence this since these are non-food crop, and it translates to lowering the cost of bioethanol. Furthermore, the commercial farming of these plants by farmers is highly recommended as it will enhance cultivation of arid and semi-arid lands because the plant is a drought-resistant plant, also causing use of improving the land use in arid and semi-arid lands. So acknowledgement, I will wish to acknowledge my supervisor, Professor Samuel Luther, Dr. Geoffrey Mayo, Dr. Ayabe Kiblagat for their guidance and mentorship. Also, all the faculty of the Department of Chemistry and Biochemistry, I thank them. I also thank the technicians of University of Eldoret for provision of operators and equipment. I also thank Mr. Macharia of Agrochemical Company of Kenya at Moroni for the supply of the industrial yeast which I used. Thank you for listening.
Okay, thank you. Thank you, Gor, for that very interesting discussion on alternative sources of bioethanol, which are cheaper. And now I just want to open the field for anyone who may have a question or a comment on that very interesting presentation. Okay, I don't see any hand which has been raised. So once again, I thank you, Kagor, for that interesting discussion. Thank you.
Thank you, please.
Yeah, now we have come to the end of this discussion or this presentation, because there were some two presenters who we could not get in touch. That is Dr. Patrick Sula and Delphine Nerima. We could not get those two, and therefore we are going to stop or to end this parallel session at that point. And I thank for all of you who participated in this session. And now I return you back to the chair of the conference. Thank you.
Christophe in Belgium. So those who are in the main conference hall, we leave to the next room for health break. Those who are online, you join us at 11 using the main conference hall link, not room 1 and 2, the main conference link at 11. Okay, thank you.
The University of Eldoret is a modern university situated approximately 9 kilometers northeast of Eldoret town in Uasin Gishu County, Kenya. Founded in 1946 and converted to a teachers training college in 1984, in 1990 it became Chepkoilel campus of Moi University, offering natural, basic and applied science programs. In August 2010, the campus was upgraded to Chepkoilel University College, a constituent college of Moi University. Upon the award of charter by the President on 11th February 2013, the University College was renamed University of Eldoret. Our vision is a premier university that nurtures global leaders and innovators. Our mission is to provide quality education, training, research and consultancy in science, agriculture and technology to meet the needs and aspirations of a dynamic society. The University of Eldoret is ISO 9001:2015 Quality Management System certified. The university is led by the Chancellor Ambassador Professor Judith Mbula Bahemuka, who is the titular head of the university, the council comprising of the chairperson and members, and the University Management Board led by the Vice Chancellor Professor Teresa Akenga. The other members comprise of Deputy Vice Chancellor Academic and Student Affairs Professor Ruth Otunga, Deputy Vice Chancellor Administration and Finance Professor Wilson Ngetich, Deputy Vice Chancellor Planning, Research and Extension Professor Philip Raburu, the Registrar Academics Professor Paul Taruz, Acting Registrar Administration CPA Francis Ikapel, Registrar Planning Dr. Benjamin Mwasi, Acting Finance Officer CPA Ereu Totona, and Senior Legal Officer Mr. Stephen Anditi. University of Eldoret is science, agriculture and technology based and has grown steadily from the initial schools of forestry and science to the current 9 schools with 34 academic departments. The schools are led by a team of deans who also provide academic leadership and management of the faculty. They include Dr. Oliver Kiplagat, Acting Dean, School of Agriculture and Biotechnology, Professor Robert Otuya, Dean, School of Business and Management Sciences, Dr. Paul Odwori, Dean, School of Economics, Professor Kisilu Kitainge, Dean, School of Education, Dr. Julius Kolongei, Dean, School of Engineering, Professor Gelas Simiyu, Dean, School of Environmental Studies, Dr. Jacob Onyango, Acting Dean, School of Human Resource Development, Professor Boaz Kaunda Arara, Dean, School of Natural Resource Management, Professor Samuel Luta, Dean, School of Science, and the Dean of Students, Dr. Lelei Kiboi.
This is one of the big schools in the University of Eldoret with several programs covering all the fields in agriculture, both at undergraduate level and postgraduate level. Also, we have some diploma programs. We strive to be a center of excellence in agriculture, as our vision is to be a center of excellence locally and globally in agricultural sciences, technology development, and transfer. We have a total of 6 departments within the school, which are under the dean. So we have a wide range of courses, and our students are not limited to work in agriculture, although most of them work in agriculture, but we have other options which are not traditionally agricultural enterprises, but nowadays employ our students.
The School of Education is the largest school at the University of Eldoret. We serve about 50% of the total student population. The school is housed at the main campus in the education complex and also at the town campus located at Musco Towers opposite Sirikwa Hotel, Eldoret town. The School of Education is organized in 8 departments. We at the School of Education prepare teachers and trainers to be employed by the Teachers Service Commission and the Public Service for Technical and Vocational Education teachers. Our graduates go into industry and private practice. The School of Education programs are highly popular due to the many avenues for employment after undertaking the courses. Graduates can go into teaching, they can go into industry for technology education, and also some establish their own businesses.
The School of Engineering. The School of Engineering was founded in 2011 with 3 departments which are fully accredited by Engineers Board of Kenya. The first department is Agricultural and Biosystems Engineering. The second department is Civil and Structural Engineering. And the third department is Mechanical and Production Engineering. All the above 3 programs ran for 5 years. The School of Engineering has actually a number of unique strengths. The first one is that we have qualified and dedicated staff with varied experiences in different fields of engineering. Secondly, our programs are marketable, both at graduate and undergraduate level. We also have excellent teamwork among academic and technical support staff and also with students. We also have good cooperation and networks with neighboring institutions, industries, and other stakeholders. Without also forgetting, we are also located in a serene environment next to a fast-growing city. The School of Engineering has 4 administrative units. Mainly, apart from the 3 departments I've mentioned, we also have the school, the Dean's Office.
I am Professor Samuel Luther, Dean School of Science, and an Associate Professor of Chemistry. We have a mission and vision. Our vision is to be a vibrant center in excellence in generation of scientific knowledge. And our mission is to create, innovate, disseminate scientific information through quality teaching and research. As a school, we have 4 departments, namely Department of Chemistry and Biochemistry, Department of Physics, Department of Mathematics and Computer Science, and Department of Biological Sciences. We offer programs both in pure and applied sciences, and our programs are market-driven and sensitive to global trends in terms of innovation.
The university has directors who coordinate the formulation, review, and implementation of university policies. They include Dr. Victor Kimeli, Directorate of Information and Communication Technology, Professor Donald Otieno, Director Quality Assurance, Dr. David Waswa, Director Strategic Planning and Performance Contracting, Professor Beatrice Were, Directorate of Board of Postgraduate Studies, Professor Vincent Sudoi, Director Research and Innovation, Professor Grace Cheserek, Directorate of Industrial Linkages, Partnerships and Collaborations, Professor James Olekiapi, Director Resource, Mobilization and Strategic Initiatives, Dr. Geraldine K. Motola, Director Gender Equity and Diversity, Dr. Nicholas Rope, Acting Director, University of Eldoret, Eldoret Town Campus, Dr. Nicholas Macau, Acting Director, Open, Distance and E-Learning, and Engineer Emmanuel Kinyor Mutai, Acting Director, Income Generation Units. The university operates 2 nursery schools, 2 primary schools, and a secondary school. The University of Eldoret has a town campus for evening and weekend classes that is located at Musco Towers opposite Sirikwa Hotel, Eldoret Town.
Welcome to University of Eldoret Town Campus. We are situated in Central Business District in Eldoret in a serene environment, conducive for learning. And we have several courses, programs in the campus from different schools, majorly School of Education, School of Business Management, School of Agriculture, School of Environmental Studies, and also short courses. These are vocational courses based on needs assessment. These are people who are working and there are some skills that they require. So we develop such courses and we offer here in town campus. So the mode of delivery here is that we offer these courses evenings and also weekends and also full-time. There are those students who are not engaged because mainly these are students who are self-sponsored, and there are those who are not also maybe engaged elsewhere. They are not working, so they can also come in as full-time students. So we admit our students in January, May, and also September. So the course is actually tailored so that a student can finish within a shorter period, unlike in main campus.
We also have Nairobi Liaison Office at Pension Tower, 12th floor, Loiter Street, for efficient resource mobilization, corporate marketing, stakeholders meetings, and university meetings.
Welcome to the University of Eldoret,
the flame of knowledge and innovation.
We are the best university in this country.
Okay. She's talking? Yes. But you can't hear? So are we ready to go?
Okay, Prof. Prof.
Not yet.
Hello, Prof. Hello, Prof. Yes, we are ready. The technical team is just hooking you up, and then you take it away. Thank you.
Okay. So we can start, eh? Okay. Prof. Sema. Okay, thank you. I welcome all of us to this, the second session for the day. We have had a very nice part in the morning where we had the various parallel sessions. We are coming to this session where we are going to have two keynote speeches. The first one will be given by our Vice Chancellor, and I'll take maybe a few minutes just to go through her biodata, just to appreciate her work in research and academia. So I'll go through the biodata of our Vice Chancellor. So Professor Kaka is a chemist by training with vast experience in training, mentorship, leadership, and management, having worked in various academic and administrative roles in East Africa. She's the founding Vice Chancellor of University of Eldoret. As a trained graduate lecturer of chemistry and mathematics, Professor Kenga holds a PhD in organic chemistry, particularly organic synthesis, from the University of New South Wales, Australia. She also holds a Master's of Science degree in Business Administration, Corporate Governance from KCA University, Nairobi. She also holds a Master of Science degree in Chemistry from Kenyatta University and Bachelor of Education, Science, Chemistry Mathematics option, where she got a first-class honors from Kenyatta University. She is a member of various professional bodies and associations, among them being the Royal Society of Chemistry, MRCS, based in the United Kingdom, the Kenya Institute of Management, based in Kenya, the Kenya Chemical Society, based in Kenya, and also she's a member of International Interdisciplinary Consortium, ICC, a consortium of universities from Kenya, Uganda, and Nigeria. She's also a member of the Forum for Women Vice Chancellors in Africa, FAWOVC, where she's the vice chairperson. She's also a member of the Organization of Women in Science for Developing World, OSWD. She's also a member of the Executive Committee of Inter-Universities Council of East Africa, IUCEA, and a Human Resource Committee member of the Implementation Committee of the Interpublic Universities Council Consultation Forum, IPUCCF. She's also a member of the Forum Board Executive Committee. So in terms of academic activities, she's accredited for publishing over 40 journals, which are recognized regionally and beyond. She has managed to teach, supervise, and mentor students, including over 5 PhD students to completion, over 10 master's students to completion, and also undergraduate students. She has also served as a reviewer in various articles in scientific journals, and she's a member of several editorial boards. For her contribution to training, research, and curriculum development, she was awarded the Moran of Burning Spear by His Excellency the President of the Republic of Kenya, Uhuru Kenyatta, in 2013. In November 2020, she was honored by the Asian Confederation of Businesses in conjunction with World Education Congress as the best woman in education leadership in East Africa for her distinguished role in enhancing the levels of higher education in the region and beyond. So members, you can appreciate from the biodata the contribution that our Vice Chancellor has made in the field of academia and also administration. And it's now my great pleasure to welcome each one of you to listen to a talk which is current, touching on current phenomena, COVID-19 and other issues, which I think she'll be best placed to talk to us and enlighten us on the science of a talk. So the title of the talk is Using Chemical Sciences to Harness a Rapidly Evolving COVID-19 Situation, a socially distanced tale of mask, the wash, the jab, and the pill. Thank you. Welcome, Professor Akenga, our Vice Chancellor, to give us the talk. Thank you.
Thank you very much, Professor Luka. I hope I'm audible now. Are members hearing me? Can I hear confirmation from Professor Kunta?
Yes, yes, we can hear you loud and clear.
Thank you. At Dedan Kimathi University of Science and Technology. So I appreciate that. Thank you for that humble introduction. And you've read through the title. I'll just repeat: Using the Chemical Sciences to harness a rapidly evolving COVID-19 situation, a socially distanced tale of the mask, the wash, the jab, and the pill. Indeed, as an academician and as a manager, I'm expected to execute my duties both ways, and being a member of the Royal Society of Kenya, Royal Society, I'm expected to actively contribute to science. And as such, I would like to take you through my thoughts on this topic. I may not exhaust it because of time constraints, but I believe at the end of it, all of us will have a picture on, will have an understanding of this tale of the mask, the wash, the jab, and the pill. I'll start by looking at the WHO dashboard and the ominous backdrop to the COVID-19 scene. This dashboard, I accessed it just a little while ago, the 15th of March. And it's clearly showing that there have been 479,635 confirmed cases of COVID-19, including almost 6 million deaths. And to give us hope, according to this dashboard, almost 10.7 million people have been vaccinated. When we come to the Kenyan situation, again from the same dashboard, I accessed it on 3rd of January, 2020. It's clear that Kenya has had 323,165 confirmed COVID cases, of which we've had almost 5.6 deaths reported. But again, there's hope. We've managed to have almost 17 million vaccine doses being administered. Indeed, when we talk about COVID-19, the true deaths reports or the records that we are receiving may not reflect the true picture. And all of us have experienced it worldwide with various COVID-19 variants, especially the Delta 19 that was easily spreadable, and it had a very big impact in one of the countries. Indeed, it's not easy to tell the correct statistics whenever we read them out. But what we know, people are recovering from this disease. Initially, it was a kind of death sentence, but when people recover, you'll notice some changes in the brains, or it has been noticed, there are changes in the brains, and that's what we refer to as long COVID. It is a bit disturbing, but we hope with the rapid technological advancement, this issue of long COVID will be sorted out. The COVID pandemic, when it was declared in 2020, actually it caused a lot of pain to many families. The world panicked. Some people thought it was demonic, and actually it was predicted that it's going to be an apocalypse in Africa because of the nature of the health facilities or status in this continent. You can see it exerted a lot of pressure both on medical facilities and healthcare givers, and most of them became victims to this disease. And Related to that, the scientists had to wake up. As scientists had to carry out revolutionary research to save the world from the grip of the COVID-19 pandemic. They put on all kinds of ammunition. They used all kinds of techniques. But thank God, there had been advances in science and we were able to move very fast. We all know this animal called SARS-CoV-2. Initially, it used to be drawn in the color red. You can see I've put it in purple, and the spikes are not red. They are somehow toned down in terms of color. It means that we are overcoming this animal, and we all know the structure. We all know the spikes, the nucleocapsid, the membrane, the envelope, and the ssRNA. The story of how this virus came about is long, and I don't want to go into that because so much has been said about it. The WHO has addressed it, and we are saying now we are past that. We have to move forward and take care of the spread of this and contain it so that it becomes an endemic instead of a pandemic. So the scientific offensive against the COVID-19 pandemic involved various multifaceted approaches. First of all, it was known that the virus spread so easily between human beings, and the issue of social distancing had to come in. Then it was known that the virus spreads through the air. We had to bring the masks. The virus depends on hygiene. We had to bring the issue of wash using even detergent or soap. Then along the way, the jab came in. And when I talk of a jab, I mean the vaccines. Then along the way, we have efforts towards developing the pill that can treat this virus. So in my talk, I'll look at each of these approaches and just give you a preview of what was found. Now, with social distancing, this was meant to reduce mixing of susceptible and infectious people. It brought in the contact tracing. Sorry, there's somebody with the mic on and there's a background noise. Can it be attended to? Are we together, Professor Luther? There seems to be interference from somewhere, but that can be sorted out, and I hope people at least are hearing me. Dr. Stephen Barasa, can you confirm if you're hearing me?
I'm hearing you, Professor.
Thank you. So there was the social distancing, and you can see the curve, the first curve here. The red is showing a situation where we have the curve without social distancing. You can see it is sharp. And the one with social distancing, where we even had lockdowns, we can see it is in blue and it's kind of flattening off, but it is still affecting the healthcare capacity. Now, to flatten the curves, for those of us who know about that, collective action had to be taken and to help the healthcare facilities manage the increased demand for care. And the collective action included quarantining infected individuals and their families. There was workplace distancing and even closure of learning facilities. Here in Kenya, you saw we closed all the schools for almost a year. The universities were closed for almost 8 months. And we had to move to online learning so that to reduce human contact. And we had to really shed off one of our cultural habits of handshaking. And as we did that, indeed, the curves you can see are being flattened, and the healthcare systems were able to manage and take care of the infected people. So that is one way the scientists came in and said we must approach this from an army point of view. The next one was the masks, the story of the masks. We all know the mask mandates that various governments implemented or put in place. And the mask is not new to the human race. Right from 1910, we had the masks in place, and the mask has evolved, as you can see from this diagram. The masks have evolved. Up to now we have an electrical smart mask. I don't know if it has reached Kenya. It has all kinds of protective facilities, as you can read from my show, but the cost is almost $100 US, which is not affordable. And it will just be good to bring up the fact that currently in the country, the government has relaxed the mask mandate, but since people were really used to wearing the masks, really the masks have become part of their daily fashion, and wherever we are always in the masks. And the masks played a very important role in that they contained the spread of the virus. Then the next came the hand wash and sanitizers. We know the properties of the virus. Those spikes can easily be broken by a simple detergent, and the hand washing and the issue of hygiene came in. This slide is showing the efforts that University of Eldoret put in place to make sure that we protect our students, our staff, and the other stakeholders. A number of experts came together and put up a foot-operated hand washing machine, which you wash your hands without getting in contact with any part of the machine. It's only your foot that operates. In here, we have the detergent, and then the water is being supplied from the water source. We also had to call upon the Department of Chemistry to come up with various disinfectants, various, what do you call them, sanitizers, and this really helped reduce the infections in the university. But as a university, we kept on hoping that this pandemic will end, and we formed a post-pandemic committee. And the committee worked tirelessly to make sure that we were ready for the end of the COVID. And it has not ended, but we were fully prepared, and we managed to reopen our university and resume our business continuity based on the mechanisms and guidelines we were receiving from the government. I would like to say a week will not end without the government writing a circular to various government institutions on this matter of COVID-19. And as a university, we've come up with the UOE COVID-19 Management Manual, which is normally referred to in all areas. And then when it comes to hand washing, the communities could not understand, especially the communities in upcountry, could not understand why they are being forced to wash their hands. And where I come from, you only wash your hands when you want to eat, or when the food is there. And there was this clip going around of a gentleman complaining Why are we being forced to wash our hands and yet we cannot see ugali, that is ogusuma, for us to eat? We only wash our hands when we want to eat ogusuma. So it became very difficult for the public health workers to convince the community to keep washing their hands. And through this sanitization, the rates of infectious diseases reduced, and to some extent, we ended up having health communities, and visits to the hospitals really decreased. The next is just to show the Kenyan story. I'm sure you know our cabinet secretary in charge of health. All of us had his voice. He really mobilized. He really sensitized the nation. And in this case, the Kenyan government or the Kenyan people responded accordingly. But we are saying here that the COVID-19 vaccine was developed. And in the course of that, we managed to receive the consignments using the various protocols set up by the World Health Organization, and vaccinations have taken place. And as I said earlier on, almost 17 million doses have been administered in Kenya. There's the first dose, second dose, and now we are looking at the booster. And I'm glad to say I'm among those who have already taken the booster. Now, talking about the vaccines, I don't want to go in the science of the vaccines. We all know when we were growing up, we were vaccinated against TB, yellow fever, and all that. So the scientists had already developed the models on how to produce vaccines, but with advances in technology, various vaccines against the SARS-CoV-19 were developed. And I know each one of us knows a particular one from Sinopharm, ranging all the way to Pfizer. Where I stuck with AstraZeneca, Oxford, and that's what I took. And we all know what vaccines are used for. Actually, they enhance the immune response. And in this case, science has proved that anybody who has been vaccinated and gets infected by this virus really does not suffer serious ailments as compared to those who have not been vaccinated. And I've seen cases of those who have not been vaccinated passing on, while those who have been vaccinated really managed to come through, to pull through. So that's the story of the vaccines. I don't want to go into that. There were politics around the vaccines, but I think the World Health Organization managed to work around those politics, and most countries at least can say they have doses to administer to their citizens. It is just their citizens who may be resistant, and there's need for more education to make sure that citizens really take these vaccines. I was so sad to learn that in another country, they are almost throwing away, is it 9 million doses of vaccines, because they also expire, which are expiring because the citizens are not willing to take them. So there's still a lot to be done as far as intake of vaccines is concerned. Now, let me go to the pill. The first COVID-19 pill was remdesivir. We all heard about it, especially when the former US president tested positive, and this drug was used on him. It inhibits replication by terminating RNA transcription prematurely, and it has been demonstrated in vitro that it can act against SARS-CoV-2. The next one is the story of chloroquine. We woke up one morning and we were told, okay, chloroquine can treat COVID. And in that case, by the time most of us were going to the pharmacies, all the pharmacies had run out of the chloroquine and its related tablets. However, it's good to note that it is not currently recommended for treatment of COVID-19 because there's quite a lot that needs to be done by scientists to make sure that the claims are true and the scientific data to back that. Then we have imevacitine. This one interferes with the attachment of SARS-CoV-2 spike protein to the human cell membrane. And despite this in vitro activity, no clinical trials have been reported. And as such, it may not be recommended, or it has not been recommended to be used in this case. The other one is a ritonavir-boosted nirmatrelvir. You'll know that in drug discovery or in treatments, we use multiple drugs sometimes in order to get better results. And in this case, these two drugs have been put together, and it's good that they can be taken orally and that they can be taken before the patient is hospitalized. And the FDA has granted an emergency use of one of them, co-packaged, which is containing the two drugs for treatment of certain patients with mild to moderate COVID-19. Now, I come to what we are doing at the University of Eldoret, and it's related to the modern trends in drug discovery. It is polypharmacology. And this polypharmacology involves the pharmaceutical compounds that exert an effect on multiple targets in the body. So here we'll be leveraging, or we've been leveraging on African medicinal plants and computer-aided discovery research to discover such compounds that will be acting on these multiple targets of the SARS-CoV-2. We know they are the spikes, the nucleocapsid, the membrane, the envelope, and all that. So if we have a drug or a set of drugs that can act on all these at a go, then we'll have disabled the virus. There's significant interest in this area of research for drug discovery in future, because so as to improve the efficacy and reduce drug resistance. And to do this, you must do it with the computer-aided discovery. And this is one of the ways I was saying this has been an advancement in technology. Computer and artificial intelligence have come in to really help us do drug discovery in a very short time, get the necessary drug, and get moving. In our laboratories, of course, the work is unpublished. I would like to say that we've identified two compounds that have multiple or may have multiple drug targets. That's the target, the spike, the nucleocapsid, and the envelope protein of the SARS-CoV-2 virus. Now, how have we done this? We've done this by enlisting computer-aided drug discovery technology. And this was very expedient and cost-effective. If I tell you how much this cost, you will not believe. We were able to screen selected medicinal African plants for potential of anti-SARS-CoV-2. And in this case, using limited resources, we screened 1,561 Kenyan medicinal plants. You can imagine if you were to do this the traditional way of going to the field, collecting the material, and doing all that goes with it, the TLC, the what, it would have taken ages. But I must tell you, with the new technology, you can achieve much with less. We use the Swiss model software to generate the homology models. We use the virtual screening, Autodoc. There are various software that we use that are there that you can use in front of your computer just to match this. And when we did the matching and the complete genome of SARS-CoV-2, we were able to come up with 6,265 different phytochemicals that can do something on this particular SARS-CoV-2. However, when it came to narrowing down these compounds to see which of these can act on the surfaces that I showed you earlier on, I talked about the multiple surfaces. We got digitin A and carisanol, and their structures are given. And you can see from the chemistry point of view, these structures can be played around with and even improve the efficacy of this particular group. Indeed, it's just limitation of facilities, or else we'll have moved further to make sure that as Kenya, as Africans, we contribute to the discovery of the pill for this particular virus. But with time, it will be, we will make it. Details of this work will be unveiled in a forthcoming publication. And we are looking for partners so that we can take these two compounds to the next level. In this case, I would like to acknowledge my team, a team that is mostly spearheaded by Dr. Stephen Barasa, as I'm busy doing my management work. And from serial number 1 to serial number 7 members, these are students we are just trying to mentor. We took them through the program and they learned very fast, and they had to do, we cross-checked what they were doing. And really, as scientists, I will encourage you to pick, to take along the students that you are training so that they can also develop a big interest in science and become the future scientists. Secondly, as a female scientist, I would like you also to take in consideration whatever research groups you form, you bring along the female scientists. Female scientists are faced with a lot of challenges, but they're the best. They're the keenest, and they will give you the best results if you give them time. So we are also grateful to University of Eldoret. The University of Eldoret gives research grants for young upcoming scientists. We call them university research grants. We give them in batches of $500,000 to provide a foundation for researchers to do big research. We've seen some good outcome out of this. And we really want to thank the University Council for setting aside funds, research funds for the young scholars. With that, members, I wish to thank everyone for listening, and I hope with the limited time, I've given you an insight on the topic of the day, the tale of the mask, the wash, the jab, and the pill. Thank you very much, and thank you, the organizers. That's the end of my keynote address. Back to you.
Our Vice Chancellor, Professor Kenga, for the talk. I think we'll appreciate her for the talk.
I can't hear you. Dean, you are not audible.
I'm supposed to use this. Okay, can you get me, Professor? I think we have some technical problem. You can get me. Okay, thank you, Professor Kenga, for the talk. I think it was quite exciting. We have been taken through the story of COVID globally. Then we came down up to our institution on what was done, and we really appreciate the talk. And I think there was also a section of science, pharmacology, where a number of plants were screened as a potential source of compounds for treatment of COVID. And this one is quite encouraging. I'll want to open this session for questions. I'll maybe start with maybe the first set of questions, 3 questions. Could I take the first 3? So anybody with a question, comment, you can raise your hand. Or so question, comments, please.
Okay, thank you. Thank you very much, Prof. I think this was an outstanding speech, and it is very informative. A lot of insight as far as COVID-19 measures are concerned. My comment is that I think this is the way that we should go. It just takes to a different high level. Having said that, I've always been perplexed by how the trends in COVID-19 changed, especially after the new strain which was discovered in South Africa. So I tend to imagine, was this God's way of intervening for the Africans? Since there was talk of the jab apartheid, and God decided that he will bring his jab from on high. What is your comment on this?
Okay, thank you, Dr. Comment. Dr. Tuwei, can bring in your comment or question.
Thank you, Chair, and thank you, Professor Kenga, for your presentation. I just have one question, and this is a bit general. What's your view regarding the position in the country where we seem to be withdrawing so quickly from these preventive measures that you've said in regard to COVID-19? Is it over worry now that you're heading a big institution and looks like everyone is just withdrawing so fast? Thank you.
Thank you very much, and thank you, Dr. Wambu and Dr. Tuwei. Dr. Wambu is bringing in the idea of the hand of God. Indeed, there have been variants of COVID-19. I talked of the worst one, which was Delta, but there was the Omicron that came up, and we all know it's the South African team that discovered this Omicron. And the trends of the Omicron are well known. However, by the time it was coming on board or it was being discovered, the vaccines were around, and Africa as such was not really affected. As scientists, we also believe in the work of God. So we may say it was the work of God, but we believe God helps those who help themselves. I want to believe the approach the African governments gave to this COVID-19 pandemic is slightly different from the approach the Western and the other governments gave. Indeed, most African governments took the military approach, but you realize in other countries, they were talking of the rights, overstepping the rights, human rights, or rights of what? You find some people don't want even to put on the masks. To me, I believe God helped us because we took the military approach and we were very cautious, whatever the case. And that is why the African continent did not have an apocalypse as it had been predicted. For me, I saw the whole of Nairobi being wiped away. I'm sorry, that used to be in my mind, but it didn't happen. And as usual, we thank God. But it's because of the military approach we took. Dr. Tuwei is worried about the issue of the government relaxing all the protocols or some of the protocols. Really, if you listen to the government, it is telling you you still need to take care. And I will advise even members in the institution or wherever you are, please to continue taking care. But above all, to make sure that you have received the jab. Because as I earlier on said, if you have received the jab, then even if you get infected, you'll find that the impact or the effects are minimal. The government believes we are heading towards herd immunity, and I know it has the advisors who collect the data and analyze, but we are saying as we head towards herd immunity, let us not be victims along the way. Let us remain focused and adhere to the protocols and continue washing our hands, whether there is ugali or not. We will survive. Thank you.
But as we are taking more comments, there are some comments which have been made on the side chat. I will just wish to bring those of the attention of the professor. There is one from Dr. Bisem. I think she's appreciating the talk, saying that it has been very informative. Then we have the same comment coming from Dr. Wetungu, but there's a question from Dr. Lagat. So the question goes, what brain changes were observed among those affected by COVID? And is the effect reversible towards recovery? And then there's another one from Dr. Naomi Bisem. So the question is, my question would be, of the 6,000 phytochemicals, 2 selected, did the team explore the possibility of synergies in the other 6,000 phytochemicals where they don't work in isolation but work in combinations? So maybe, Professor, you can take on those 2 questions.
Thank you very much. And I would like to appreciate Dr. Bisem. Thank you for appreciating the talk, my presentation. I know you realize really being a VC is a very busy job, and getting time even to prepare a slide or presentation is another hectic job. But I appreciate my team members especially led by Dr. Stephen, for the support they have given me in all this. As late as last night, as late as this morning, you were busy interacting and refining the presentation. And that goes to Wetungu. And this is to demonstrate that teamwork is very important. Whatever administrative position you have, please team up with your members in your profession or in your career and continue advancing your career with them, working together, so that when all is said and done, you contribute fully to mankind. Now, Dr. Lagat, I was a bit skeptical of projecting that slide, but I thought if I didn't, I'll not be talking the truth about the COVID-19. Indeed, I just want to assure us that scientists are working hard to address this issue of long COVID. And I'm sure in no time we'll have a reversal or some kind of remedy to make sure that things go back to normal. We've all interacted with one or two people who have got this particular infection, and you'll agree with me, there is the issue of long COVID, and it will be addressed. I'm sure it is being addressed. Dr. Bisem, you are looking at synergistic actions of various chemical compounds. Indeed, in the early 2000s, this was the approach. I remember carrying out a research on synergies of phytochemicals against various plant pests, and actually that proved to be very successful. And synergies are there because the chemicals come together and work together and attack or act in various, using various mechanisms to weaken the pathogens. In this case, you know, the time was limited. I think we will also pursue that, just using still that same computer-aided design research to see which ones can give us that synergistic action that you've proposed. I hope Stephen has taken that up so that we can also explore that. We may end up with more compounds. Thank you.
Any reaction, any other reaction, comments? There is one that I would wish to pick up, I think, to just encourage each other. We have been informed to try and mentor a female or a ladies scientist. And I believe the members who are here and have projects running, please try to see to it that you bring in at least a lady or a female gender to your project so that we can be able to mentor them. I think we still have that squidness in terms of training. We have very few scientists in this field, female in the field of science, and we really encourage each other that we try and see if we can be able to reverse that. Is there any other comment? Okay, Professor Sudoi.
I would like to.
Oh, I can't hear.
Yes, I wanted to appreciate the work that you have done, especially in relation to
annual research grants. I know you have done a lot of work on heavy metals, and now you are on the real thing, coffee. We have been in touch with Barasa most of the time, and I was wondering when this information would reach the people, but now it has reached because we have been enlightened on COVID-19 and some work that is going on in our university. On the issue of ladies, it is now the STI strategy that we got from NACOSTI requires that we actually be sensitive to ladies who are going to do research, gender actually. And we have put it in our research activities that when we are giving out, we consider gender. That's all what the communication I wanted to do. Thank you, VC.
Okay, thank you.
Members know that I'm working with Professor Gray for some time on the issue of heavy metals. But when this issue of COVID-19 came in, we had to reflect and see what role can we play as a university towards this drug discovery in terms to treat the COVID-19. And we had to tweak a little bit and go to the drug discovery. On the issue of ladies, really, with the university research grants, I think this is the time we can debate and agree that when we are locating these research grants, we encourage our female scientists or scholars to apply, and a certain amount should be set aside. That is, we carry out the affirmative action to make sure that the female scientists we have at the University of Eldoret and all over, because we encourage collaborative research. It doesn't mean that research just to be done within Eldoret. You can collaborate with other researchers outside the institution so that a certain amount is set aside for female scientists. And I'll be very happy to leave such a legacy behind, having set a trend to come up with strategies to attract more female in STEM. Thank you very much.
Thank you, Professor, for those insightful remarks. I think we have been
Seriously. I think at this particular point, I would just wish that maybe we bring this session to an end. As Professor said, this is something that is not ending now. It's continuing, and let's engage so that we get the solution to this problem. And I think just before we move into the next session, we'd also like to thank our Vice Chancellor most sincerely for supporting this conference. She has been very keen since the time we started up to today to ensure that things run smoothly. And we have really been supported well by the university management, and we really thank the university for that. So I think with those few remarks, you'll again join me in thanking our speaker, Professor Kenga, for the talk. So let's appreciate our speaker. Thank you.
In a bit, just to listen to Professor Christoph.
Okay.
Then after that, I will request to leave.
Okay.
To go and attend to some other urgent matters.
Okay.
Thank you.
Thank you, Professor. Thank you for accepting to stay with us longer. Now, we are sorry the other session is starting a bit late, but the speaker is on the floor already. So we have Professor Christoph, who is our second keynote speaker. We apologize, we have delayed a bit, but I can see he's already in the room. I would wish just to read his bio data as we organize to move to the next session. So this is the bio data of Professor Christoph.
remove my slides from the screen. To unshare, please.
ICT, I think you have heard. So I think as we are organizing ourselves and for the sake of managing time, I'll read the biodata of our next speaker, and I'll request the ICT to remove the slides of first speaker from the wall. So this is the biodata of Professor Christoph. Professor Christoph is an associate professor at the ENVOC Research Group in the Department of Green Chemistry and Technology, Faculty of Bioengineering at Ghent University. He holds a Master's of Science degree, which he got in 1999, a PhD in Bioscience Engineering, which he got in 2005, in Environmental Technology from Ghent University. He first joined the faculty at the Ghent University in Belgium from 1996 to 1999 as a specific teacher of the training program for bioscience engineering before proceeding for his PhD. He has been a lecturer of academic courses at the Bachelor, Chemical Analytical Techniques, Production Technology, and Master's. He has taught analysis of organic micropollutants, advanced waste gas treatment, environmental chemistry and analysis in different national and international programs at Ghent University. So he has been in the Department of Bioscience, Engineering, Environmental Science and Technology, Economics, Business Economics, and Business Engineering. Also, he has been in the Institution for Permanent Education. In the last 10 years, he has held the position of an assistant professor at the ENVOC Research Group, Department of Sustainable Organic Chemistry and the Technology, Faculty of Bioscience Engineering at the Ghent University from 2009 to 2014. And he became an associate professor at the ENVOC Research Group, Department of Green Chemistry and Technology, Faculty of Bioengineering at Ghent University since 2014. His research interests include chemical analysis of trace organic compounds in ecosystems, sample preparation, gas and liquid chromatography, advanced mass spectrometry, environmental chemistry, the occurrence, fate, behavior of emerging organic micropollutants, biological and physicochemical air and water treatment technology, biofiltration, precipitation, adsorption, advanced oxidation, ozonation, peroxone process, and heterogeneous photolysis. Professor Christoph has published extensively. He has over 127 publications in peer-reviewed journals, over 150 chapters in books, and abstracts for proceedings of Congress, posters, oral contributions at national and international conferences and symposium. He has over 4,900 citations in 4,343 journal articles. He has mentored numerous students as promoter or co-promoters of approximately 60 master theses, 11 doctoral dissertations, and currently co-supervising 10 ongoing PhD studies. He serves as a Secretary of Thesis Defenses of the Master of Science in Bioengineering Department, Environmental Technology. He has held various leadership positions one being chair of Educational Program Committee of the Master of Science in Bioscience Engineering, Environmental Technology, with also active participation in educational quality control activities within the faculty. He has also been an external tutor. He has coordinated programs at various levels. He has also been a co-chair of steering committees of the University Center of Excellency, MS-SMALL, that's mass spec for small organic molecules. He's a member of the seed group of the European Water JPI Knowledge Hub on contaminants of emerging concern between 2019 and 2021. He has also been a European WSSTP working group on contaminants of emerging concern. He has also been a member of the International Ozone Association, the Belgian branch of the International Water Association. So he's also a member of CKO, the Commission for Educational Policy at the Faculty of Bioengineering and the Interfaculty Center of Environmental Science and Technology and various advisory boards. So you can see it's a rich biodata, and I'm sure we are going to gain a lot from his talk. So the title of the talk by Professor is Contaminants of Emerging Concern in our Aquatic Environment, Chemical Trace Analysis, Novel Ozone-Based Water Treatment for their abatement. So Professor Christoph, welcome and give us the talk.
Thank you very much, Professor Rudolph, for this kind introduction, and particularly welcome to all of you. I would say in Ghent. We're a little bit far from each other, but I hope we can feel rather close during this presentation. Thank you very much for the organizers, for inviting me to give this lecture. It's really an honor to be with you, and I see it also as an outcome of the long, fruitful, and very pleasant collaboration we have already for years now between Ghent University in Belgium and between University of Eldoret in Kenya. There are some colleagues, among which the chair of this session, we are collaborating for years, and I must say this has been always a very interesting, inspiring collaboration with many people involved at different levels. And before I give my talk, I would like to express my appreciation for this long and successful collaboration. That has been said, I will focus now on the presentation. The topic of today is indeed contaminants of emerging concern in our aquatic environments. And I will focus a bit on the analytical challenges to measure these contaminants, and also provide you a kind of a technological solution to obey them from our contaminated water resources. I hope the slides are moving. Yes. So I would like to start with a quote. Water is not a commercial good, but a common heritage we must protect, defend, and acknowledge. I think that we are all very aware of the fact that water is a very critical resource we have to manage in a sustainable way. And yeah, we are aware of the fact that water is under pressure in terms of water quantity, and climate change effects will not improve this phenomenon. Also in countries like Kenya, I think you are experiencing that to a very much extent. But apart from water quantity, of course, there is also the issue and the challenge of water quality. And certainly if there is less water available, we should make sure that the water that we have still available is of good quality. And quality is, of course, a broad word, and it means that water is put under pressure in terms of physical contamination. We have plastics, we have microplastics in our water. We have microbial contamination, and of course, we also have chemical contamination. Part of that contamination is very clear. If you see oil spillage in our oceans or seas, well, this is chemical contamination that is very visual to all of us. But a large part of the chemical contamination that we are encountering is actually not visible. It's dissolved in the water phase, and we cannot experience it as such, but it is there. And one group of contaminants that is important and is becoming more important is a group of what we call the contaminants of emergent concern. It's a term of well, it's actually it involves really a very broad diversity of all kinds of chemicals. It does not mean that these are all new, unknown pollutants. On one hand, there are contaminants, new pollutants that we discover in recent years, and for which we have to be honest and on scientific level, and we have insufficient data to really fully assess their occurrence, their risks, human and ecosystems. On the other hand, there are also well-known pollutants, well-known chemicals that we are aware of the fact that they could be in our environment, but that we only have recently detected. And this is because, of course, the analytical possibilities have really improved over the last decades, which makes it possible to bring into chart the occurrence of pollutants that were not discovered before, at least not in the environment. And this group of chemical, of contaminants of emergent concern are at the level that actually, because of the novelty of this contaminants, that they are most often not translated into legislation or policy guidelines, although on different levels one is working on that. But at least we are aware of that, and there is on a scientific and a societal level, there is a really emerging concern about the occurrence and the effects of these contaminants. Which makes that, for example, in Europe, in different policy frameworks and in different working groups, a lot of debate, scientific debate is going on to see what should we do with this enormous diversity of contaminants of emergent concern. How should we monitor them? How should we manage them? How should we abate them? How should we assess the risks? And this is a bit the framework, let's say, of my talk of today. To make it a bit more clear, why is there concern? Why is there emerging concern about this contaminants in our water resources and our aquatic environment? Because there is a growing evidence from science that once these chemicals are released into our water resources, they can indeed induce both environmental and human effects. And on this slide, I have summarized a number of different harmful effects that are possible after exposure to this contaminants of emergent concern. And you see it's quite diverse. It goes about hormonal disruption. We are talking about endocrine disrupting chemicals. It goes about toxicity. We must say mostly it is a form of a chronic toxicity and related to the mixture of chemicals we are exposed to. There are ecological effects like behavioral changes. If, for example, fish populations are exposed to pharmaceutical residues, there is a risk of antimicrobial resistance if our environment is exposed to residues of antibiotics. And there is a risk for some compounds of accumulation in the food chain, that at the end makes also human people being exposed to these chemicals. To give you examples of what kind of contaminants we are talking about, I listed here 3 groups, not 3 chemicals, but 3 groups of chemicals that we consider as contaminants of emerging concern. And these are pharmaceutical compounds, pharmaceutical active ingredients, pesticides, and personal care products. Of course, we should be clear, and if we are talking about pharmaceutical compounds, for example, I think that the first thing that we should say is that we can only be very happy and thankful that we have this kind of chemicals in our society. I think we also heard from the previous talk that indeed without these pharmaceutical compounds, we should have encountered even more problems than we have now. On the other hand, we should be aware of the fact that this type of chemicals are developed with a certain bioactivity. They have been developed to really interfere with the biological activity, for example, in the human body. As long as this is used in a very targeted way, this is of course curing, and this is a positive effect. The challenge raises when these compounds are released into the environment through different pathways, and when they can express their bioactivity in an untargeted way, and in a way that is not intended towards organisms that were not intended to be cured by, for example, this pharmaceutical compounds. And this is how we look in environmental sciences to residues of these contaminants of emerging concern and about the potential risks that are related to that. Good. This is, let's say, the introduction. Then to come back on the first part of my talk, what is now the challenge from a chemical point of view in terms of in relation to this CECs, contaminants of emerging concern. The fact is that these chemicals occur in the environment at really low concentrations. We are talking about concentration levels in the order of microgram, even to nanogram, or even lower, nanogram per liter. This is what we call trace compounds, trace level concentrations or sub-trace level concentrations. And to give you an idea, 10 nanogram per liter, for example, this is a concentration. If you should dissolve 1 cube of sugar in an Olympic bath of water, this is more or less the sugar concentration that you can expect. So just to give you an idea on how low, let's say, this nanogram per liter level really is. Now, of course, if we are talking about water, we can talk about different kinds of water resources. We can talk about wastewater. We can talk about our surface water, our aquatic environment, and river water or marine water. And we can talk about drinking water. Okay? And depending on the local situation, depending on the types of treatment that has been performed on this different types of water, we can expect that the concentrations go down if we consider wastewater, for example, compared to drinking water. But anyway, concentrations are there, concentrations are low, are hard to measure, and they occur in very complex matrices. Because we should be aware of the fact that, of course, we are now focusing on these contaminants of emerging concern, occurring at this really trace levels, but in these water bodies, there is much more. There are the bulk or organic compounds, there are the nutrients, which occur at milligram per liter. This is orders of magnitude higher. And so we are looking for this particular contaminants within this very complex matrices. And that makes it challenging from an analytical point of view. That's also the reason why many of these contaminants of emergent concern have only been detected in the last decades. And before we didn't have the analytical tools, let's say, to measure them, we were not fully aware of the fact that they could have that they could occur in the environment. So how are we dealing with this analytical challenge? Well, it means that to measure this contaminants of emergent concern, we need a full and entire analytical process. And that starts from sampling up to sample preservation, sample pretreatment, and at the end, we need instrumental analysis. Well, here again, I show on this slide the different types of water that we can imagine, and you see the complexity of the water depends on, like I said, if it is, for example, percolate from landfill leachate, or if it is an effluent from a wastewater treatment plant, or if it is drinking water. It's a fully different matrix. It's all water, but it's clearly different. If the contaminants of emerging concern occur there at a concentration level of 10 nanogram per liter, just to give an example, we must say that this is at least 2 orders of magnitude lower than what can be measured directly, even by our most advanced instrumental tools, like, for example, modern state-of-the-art liquid chromatography, mass spectrometry instruments. So in one or another way, we have to deal on first hand with the complexity of the sample and with the fact that the concentrations are much too low to measure directly by our analytical equipment. So a very important step in our analytical process and analytical train of different steps that we have to do with our samples is what we call sample preparation, and what many people and what also we are using in our laboratory is the solid phase extraction technique. And it means that we will load our sample on a cartridge. In that cartridge, there is a kind of a sorbent, and on the sorbents, we will pre-concentrate our analytes. So that, for example, we load 100 ml of sample on the cartridge. We hope that all the analytes are retained by the sorbents, and at the end, we will elute the same amount of analytes, for example, in 1 ml of pure methanol, just to give an example. In this case, we should have an up concentration of 100 times analytes that initially occur at a concentration of 10 nanogram per liter in the real water sample will be up concentrated to a concentration level of 1 microgram per liter in the extract, in the methanol extract, and that can be measured then by our instrument. So this is clearly the advantage of including the solid phase extraction step to up concentrate the samples. It also allows us, and this is less clear from this slide, it also allows us to clean up our sample, to remove all the bulk compounds and all the interfering compounds that are present in the sample so that they are not disturbing our analytical process. So with this step, actually, we reach 2 objectives, up concentration on the one hand and clean up of the sample on the other hand. Once we have this cleaned extract, we can indeed inject it into our instruments. Here I want to give you the example of what you can get from applying a liquid chromatography mass spectrometry analysis. Well, first of all, in the chromatography step, we will try to separate all the different analytes that are in the samples. We will visualize this in a chromatogram, which means that each peak represents one particular contaminant, in this case, one particular contaminant of emerging concern. And by the hyphenated mass spectrometry, we can try to identify the different analytes that we are detecting up to based on the molecular mass, and that we can provide indeed the chemical structure, so that we have a full identification. And by measuring the peak area, we can have a full quantification of the different analytes, in this case, contaminants that are in our sample. So this is how we can deal with modern instrumentation, this analytical challenge. And by this, we can start monitoring. And I would like to bring in a very recent study I noticed a couple of days or weeks ago. It's a study of 2022, which entitles "Pharmaceuticals are present in almost all the world's river." These are findings of a study which is published in the Proceedings of the National Academy of the United States of America. It's one of the most global studies I'm aware of about the occurrence of these pharmaceuticals as one group of contaminants of emerging concern in the world. So to make it a little bit more clear, samples have been collected, I think, from over 250 countries. You can see how it was distributed over the different continents in the world. And you can see here your region. This is Europe, and this is East Africa. And the more blue the country is, the more sampling sites that have been detected. It is clear from this recent study that indeed there is a worldwide occurrence of pharmaceutical residues in our aquatic environments. I think this has been demonstrated very clearly with, I think the analysis was targeted towards a list of about 60 pharmaceutical compounds. And what the researchers did was actually making the summation of all different contaminants that they measured, and then they put on the y-axis the cumulative concentration. The highest one measured in Pakistan, for example, but we should be clear, any region of the world is encountered with this challenge. I see, for example, Nairobi here, I see Brussels here, so Asia, America, Africa, Europe, you can find it everywhere. Should we be concerned about that? Well, once again, to be honest, we are, as the scientific world, has not been able to bring into chart all the different effects and the risks that this can bring with us, but at least concentration levels can be compared with kind of threshold values, for example, ecological threshold values or safe values regarding, for example, antimicrobial resistance. And then from this study, it could have been seen indeed that in a certain fraction of the sample sites that have been measured, that indeed these safe concentrations have been exceeded for particular compounds, like for example sulfamethoxazole towards the PNEC value, so the environmental threshold value, but also other antibiotics towards this antimicrobial resistance criterion, etc., etc. So just to say that we cannot ignore that, just to say that we should be aware of that, and that indeed there might be an ecological risk, there might be a risk for humans if we are not managing our water resources in a proper way. So again, this is one of the most global studies that, that have been done. This is a study we were not involved in ourselves, and that's why I also refer here to the publication, so people that are interested can have the full read. It's available. But through the collaborations that I mentioned at the beginning of my talk, and through the involvement of different people, also from your institute, staff people and master's student peoples, master students, we also did measurements in different catchments, river catchments, and we can only confirm that indeed pharmaceuticals can be detected, pesticides can be detected, personal care products can be detected at this concentration levels I mentioned in aquatic environments in the field of study. Okay, I think this brings the overall picture, let's say, and then the second part of my talk is more related to the fact on if there is an environmental concern, can we work towards solutions? And at least here I want to bring the view, the picture from the European perspective, let's say. Where in our case, the fact is that if we look on how these pharmaceuticals reach our environment, that I should not call it a source, but at least I should call it a pathway, that we can see that effluents from wastewater treatment plants are an important pathway through which pharmaceuticals enter the aquatic environment. And this is quite logical because the wastewater treatment plants that we have in Europe and our country have been built 20, 30 years ago at the moment where there was much less knowledge and concern about these contaminants occurring at trace levels, about this organic micropollutants. The wastewater treatment plants that we have in Europe mostly consist of a primary treatment and a secondary treatment. The primary treatment is more for the physical pollution removal, the fat removal, the sand removal, the suspended solids and things like that. Then the main part is the biology. We have activated sludge systems, for example. In the biology, the COD, the chemical ozone demand of the water is heavily reduced, nutrients are removed, and these both steps do their job very good. I mean, very good in the sense that they are doing their job for what they have been designed. They have been designed indeed to remove this type of pollutant, which they are really removing. But at that moment, micropollutants were not really of concern. So that means that these two steps were not intended to remove micropollutants. And what we see is indeed some micropollutants are removed to a certain extent, but many micropollutants are just passing through. So let's say that our treatment plants, like they're operating now today, in Europe are not fully effective, are not sufficiently effective to remove micropollutants, the contaminants of emerging concern. They pass through, and with the effluent, they come into the aquatic environment. That brings me to the fact that on a European level, there's a tendency going on to say that, well, if you want to tackle these micropollutants, if you want to remove them also from the environment and from the effluents of our wastewater treatment plants, that maybe we not only need a primary and a secondary treatment, but we also will need in future a tertiary treatment, particularly designed to remove these micropollutants. And then the question is how to do. Well, one particular strategy that we can follow, and this is also part of the work we are doing in our laboratory, is to make use of ozone. And so the second part of my talk will go on the potential of ozone application to remove micropollutants from wastewater treatment plant effluents. So what is the idea? Ozone-based advanced oxidation, part of the solution, that's the question. Well, ozone, if you want to use it in a technological way, you have to generate it from pure oxygen or from air. And this ozone is bubbled, for example, in the water that we have to treat. The main focus here is to remove micropollutants. So I just represented the different type of micropollutants by these green dots. And what you can expect, or what happens from a chemical point of view, if you dose ozone into this water stream, you can have two types of reactions. On one hand, you can have a direct oxidation. I mean, a direct reaction between ozone molecules and the contaminants of emerging concern. This is one pathway of chemical reaction. The second one is that if you bring in ozone into water, you have a kind of chemical reactions going on, which at the end lead to the production of hydroxyl radicals. And hydroxyl radicals are very powerful oxidants and are non-selective. And this is in contrast to ozone. Ozone is also a powerful oxidant, but it's very selective. It will not react with any chemical. It will only react with certain types of chemicals. Hydroxyl radicals react with almost everything. But these are the two different ways that you can have during ozonations, the two different chemical pathways: direct oxidation by oxygen and indirect oxidation by these non-selective hydroxyl radicals. And by this, or through these two pathways, you really can indeed degrade, remove and degrade for example, the pharmaceuticals. This is the theory, and this works well, but there is a challenge. And the challenge that we encountered is the fact if you apply this in real matrices, because in real matrices, you do not only have water and the micropollutants, but like I told already in the beginning of my talk, you also have the bulk compounds that are in the water. the bulk organic matter, like the humic acid, the fulvic acids, the proteins that are in the water. And these occur at very high concentrations relatively to the micropollutants, to the contaminants of the merchant concern. So what is the challenge now? If we apply ozonation and we generate ozone on one hand, but hydroxyl radicals on the other hand, that's a large extent of these hydroxyl radicals will not react with our micropollutants, but they will react by this bulk organic matter, for example, which is much more abundant in the water. So we are doing a lot of efforts to introduce oxidants in our water, but they are not used in a fully effective way, because they are scavenged. We call this scavenging, and these radicals are scavenged by the matrix, let's say. They are not used effectively for the micropollutants removal, but they are scavenged in an ineffective way, in a more ineffective way, by the matrix compounds like the bulk organic matter. This makes that at the end, ozonation still proves to be an effective technology to remove micropollutants from water, but we have to dose higher ozone concentrations to make it effective in real waters, which increases also the cost. That's why we were thinking in the group and also broader, how can we solve that problem? The idea that we have was, well, maybe apart from dosing water, apart from dosing ozone and the water, maybe we have to add a second chemical is called PMS, peroxymonosulfate. Why were we thinking about that? Because if you add peroxymonosulfate in water, it also reacts with ozone. So there's a reaction between PMS and ozone, and that gives us these two radicals. And by water chemistry, these radicals are converted on one hand into sulfate radicals, and on the other hand to hydroxyl radicals. So that means in the ozone PMS process, we do not only have ozone and hydroxyl radicals, but we do also have sulfate radicals. And sulfate radicals have the advantage that they show a higher selectivity compared to hydroxyl radicals. It means that we expect that they will more selectively react to our micropollutants and less extensively scavenged by our bulk organic compounds. So that was the idea. And then, of course, we had to investigate the performance of this novel ozone PMS process. We did it in 2 steps so far. The first step was to learn about the fundamentals of this new ozone PMS process. And this has been done in a clean water matrix and demi-water, which have been spiked with different micropollutants. This is just to give you an idea about the setup. So we spike with different target compounds like atrazine, metronidazole, so pesticides and pharmaceuticals, which have the common characteristic that they are not very reactive with ozone. So that means that the removal is mainly based on oxidation by hydroxyl radicals, because the direct oxidation is not very fast. And the concentration that we spiked was 5 micrometers. We did it in a quite simple system where we added the ozone and where we added the PMS, the peroxymonosulfate. So to make clear again, we compared the 2 processes, let's say the classical ozonation process and the novel ozone-based PMS process. This is our new process. If you add ozone, you can remove the micropollutants by either ozone and hydroxyl radicals. If you have the ozone PMS process, you have the same, but additionally, you have sulfate radicals. We were very interested to learn on what was the contribution of these different oxidative species. And therefore, we used an approach where we added tertiary butanol as a scavenger for OH radicals. We did this in both processes. So if you add this scavenger, the reaction is only going on with ozone. The same is true in the ozone PMS process. So if you add this butanol, It scavenges the hydroxyl radicals, and we also added methanol as a second scavenger because this scavenges both the hydroxyl and the sulfate radicals. So by this experimental setup, we could differentiate among the contribution of the different reactive species. To give you an example of some results, and this is a result for ketoprofen, you see the concentration level, the initial concentration over time in the ozonation process, and indeed you can see ozonation is an effective process to remove ketoprofen pharmaceutical from the water. If we add extra PMS, peroxymonosulfate, you see the reaction goes even faster. I think there was an echo in the sound. Okay, so the reaction goes even faster by this additional sulfate radicals. What is the contribution of the different species? Well, therefore, we added tertiary butanol in the ozone process to exclude hydroxyl radicals, and then you see indeed that the removal is much less efficient because of the fact that ketoprofen is not reacting well with ozone. If we do the same in the ozone PMS process, we also see from the blue line to the orange line that by scavenging the OH radicals, the process becomes less efficient, but it is even much more efficient than the ozone process. And this is because of the contribution of the sulfate radicals. So that is was a very good result, because indeed it proves that if the OH radicals are scavenged in one or another way, that because of the presence of the sulfate radicals, that you still have a very good removal. We have a similar result for metronidazole, another antibiotic, another pharmaceutical. So you see that the degradation with ozone is slower than with the previous compound. But if we add the PMS, the peroxymonosulfate, that indeed we have again a very effective process. With contributions, again, both in the ozone process and in the ozone PMS process of hydroxyl radicals, but very clearly in this process, sulfate radicals play an important role in the ozone PMS process. So here we see again a summary contribution of the different species, ozone, sulfate radicals, and hydroxyl radicals in the removal of the different micropollutants. And the main conclusion is that sulfate radicals are very important in this ozone PMS process. Then we did some experiments to optimize this process, to vary how much PMS should we add to the water. We expressed that as the PMS ozone ratio. And on the left hand, you see the PMS concentration that has been added and also that has been used in consumers. What you can see from this figure is that the dose is important indeed, in the sense that the amount of PMS which is consumed at the different doses is not very different, but the effectiveness of the PMS that you dose is much higher at lower PMS concentrations. So that was for us a good result that we should not exaggerate with the amount of PMS that we add in the water, but that at lower concentrations, indeed, the effectiveness is higher. I think there is a kind of an extra microphone. Yeah, no, it's better. Thank you. And another way to improve the process was to play with the pH. And here it is clearly shown that at neutral to more alkaline pHs, that the process is becoming much more efficient than acid pHs. And this is also, let's say, a moderately good result because the pH of our effluents of wastewater is indeed in the range of pH 8 somewhere there. So the process works in the pH ranges that we need in real practice. So these were the intermediate conclusions from the fundamental research that we did in demi water. So we see a clear improvement of adding PMS in water when applying the ozonation. We see the important contribution of the sulfate radicals, and we see a more efficient use of low PMS doses and at high pH. Of course, the next step is what does it make in real waters, and natural waters and in wastewaters. So this is the last part of my presentation. So we followed a similar approach. Again, some micropollutants, ozone recalcitrant micropollutants. We used the same type of scavengers, and we applied the process, the ozone process and the ozone PMS process in 3 real water matrices, being effluent from a wastewater treatment plant, being surface water, and being groundwater. One way to characterize these water streams was measuring what we call the instantaneous ozone demands, which gives you the values here. You see that for effluent, this is much higher than for surface water and groundwater. How to interpret that? This is actually a measure of the organic loads, or at least the loads. It can be organic and inorganic, the load of our water matrices, because this IOD expresses the amount of ozone which is consumed within 5 seconds by bulk compounds that are present in the water. Of course, if we add PMS, also PMS will react with the ozone, and then you can see that the IOD will increase, and we see that is much more occurring, much more pronounced in the less heavily loaded water matrices like surface water and groundwater. So that means that that was an indication that the PMS activation by ozone is more, you see here, and without going into detail, you see indeed that the behavior of PMS and effluent is different from what we see in surface water and groundwater. And the last 2 matrices are comparable to what we have seen in demi-water in the first part of the presentation. So in conclusion, it means that the PMS activation, giving rise to the formation of sulfate radicals, we expect from this slide that it will be more efficient and less loaded matrices like the surface water and the groundwater. We were very curious to see the effects on the micropollutant removal. So I show you the results for 2 compounds, atrazine on one hand, a pesticide, and chloramphenicol, an antibiotic on the other hand. You see the removal by ozone, these are the blue bars. You see the removal by ozone PMS, these are the orange bars. I think it is clear that in any of the matrices, the PMS addition improves the process, but that the improvement is indeed, like we expected from the previous slide, more pronounced in less heavily loaded waters. The radical contributions learned us that although the sulfate radicals play a very important role in demi-water, that their contribution is less pronounced in real waters. And this was a bit surprising for us, because the intention was to produce sulfate radicals, and we indeed see orange bars a contribution of the sulfate radicals to the removal of the micropollutants. But compared to demi-water, demineralized water, the process becomes more dominated by hydroxyl radicals. And these hydroxyl radicals that are generated, of course, also contribute to a better improvement, but they are more prone to this initial scavenging effect. So this is more or less where we are today, and we are now unraveling why there is a different contribution of sulfate radicals and hydroxyl radicals in clean water and in real waters. And at this moment, we are thinking in the direction of the fact that not only the organic matter, but that also inorganics like chlorine, for example, might play an important role, that because of chemistry, water chemistry, the reaction between sulfate radicals and chlorine anions can indeed convert through a number of reactions the sulfate radicals at the end to hydroxyl radicals, which makes that in real waters containing a lot of chlorine, that indeed the process becomes more hydroxyl radical dominated instead of sulfate radical dominated. But the work is not done, and we should further unravel these mechanisms to further improve our process. So the conclusions of the second part, the performance of ozone PMS is clearly influenced by the load of the matrix. It has more impact, more positive impact in surface water and groundwater compared to effluent, which is which contains higher loads of organics and inorganic bulk compounds. Sulfate radicals still play an important role, but it's more limited compared to demi water. And we can use indeed the IOD as an indicator to estimate the effectiveness of the ozone PMS process. This is actually the end of my talk. I hope that I could bring you some data on the occurrence of contaminants of emergent concern in our aquatic environment worldwide. This is a worldwide problem. But I could point you to some challenges that arise to measure these contaminants in an accurate way, that it really needs a lot of analytical efforts, but that's with the modern instrumentation that we can do so. And I hope that I also could illustrate you that there are way forwards to solve the problem by a technological approach, and that a lot of research is going on to improve the existing technological techniques, for example, ozonation that we have, to make them more efficient when applying them in real environmental conditions. And with this, I want to thank you all for your attention. Once again, I want to thank the organizers to give me the opportunity to bring this talk, and I'm open for any discussion and interaction with you. Thank you.
Thank you, Professor, which has actually highlighted the use of modern state-of-the-art techniques in trying to identify the micropollutants, and really appreciate. Maybe at this particular point, I'll invite comments and or questions. So if you have a comment, kindly raise up your hand, of course through the wall, so that we can give you a chance. So comments, you can see one. So I can see Professor Okoth. You can also see another one, Dr. Naomi Bissem. So we have those three. So Professor Okoth, you can go in or come in first, and then Professor Bissem will follow.
Thank you very much. I hope you can hear me, Christoph. Christoph, I hope you could.
Yes, I do. I can see you and I can hear you. Hello.
Oh, hi. How are you? Thank you. Just members, this kind of research is just solving problems that we have, because we all know that pesticides are a challenge, especially in farming. Fertilizers are a challenge. Heavy metals. We have studied this time and again. Personal care products, the sprays that we use, some of us are sprayful. So all those things end up in the environment. And in the recent times, people have not been taking their drugs very well. You go to hospital, especially HIV patients, you meet most of these medicines all over, especially in water masses, near the rivers, and totally, completely packed. Sometimes only a few are used, and so on and so forth. The problem with this is that they end up in the environment in whatever trace amounts that there might be. And that's what Christoph is trying to impress upon us. These materials, or these trace amounts, are not able to be seen by naked eyes. Sometimes they are dissolved in water, among other things, and there's no policy of disposal of some of these drugs, among other things. So analytical techniques are used and to identify, to concentrate, and even to analyze them.
And at the end of it, they end up probably, some of these which are thrown away end up in the sewage system and so on and so forth. And when we clean up the sewage system, the final product, which is basically somehow to some level clean water, still end up in the water masses. And we are saying that, can we be able to clean this of the chemicals of emerging concerns? And ozonolysis is just one of them. Now, this project has actually generated quite a number of students graduated. I got into this project some time back, maybe way back in 2013. And since we have graduated a few students, Kenyan students, including Professor Koreje, Dr. Koreje, who must have taken you through some session in one of the postgraduate conferences or rather postgraduate workshops that we held. And you know very well that there's a project that is running at the Department of Chemistry, ending this year, has been running for 2 years, but because of COVID, it was extended. So it has been running for the last 3 years. And currently we have students who are on this. I'm the principal investigator in this particular project. Professor Luta is my colleague. Most of the work we have done at the Water Management Authority labs because of the challenges that we had locally. But we have even one student currently, Philip Masime, who is actually there on this project. And Faith had gone and she's around. And we are in the process of even writing a second proposal. In fact, next month, myself and Professor Luta, we should be in Belgium for this proposal writing. So we'll be looking out for some students who are interested in this kind of work. So what we are saying is that it is something that is going on and it is changing lives. Currently, the current group of students are actually dealing with how we can be able to purify water using local resources. And we are thinking of, or we are using adsorbents from local plants. And somehow we have been getting very interesting results. Because if you talk of ozonolysis or ozonation, you might not be able to work it out very easily with the common man in the, or the common lady in the village. But when you are having a filtration instrument where you have packed it with some adsorbent material, it's easy to pour inside and get whatever is clean going through it, and they are able to drink. We call them point of use water. So this is the kind of work that is going on, and just be on the alert in case we get this other grant. We might be looking out for students who can actually be able to help us with that. Thank you.
Okay, you can be same.
Thank you very much, Chair, and thank you, Prof. This was a very good presentation, and it's clearly indicating to us a very serious problem that most of us are probably not aware of. I have just 2 questions that I'd like to ask. Number one is, this is a problem that needs to be mitigated as soon as possible. And one of the questions I wanted to ask is there a way to design a dosing vector that can create a reaction that would create the ozone and the sulfate ions that can be dosed to groundwater? The reason I ask this is because most of sub-Saharan Africa use groundwater as their water sources outside the surface water from boreholes and wells. And so if there was a way that we could get the population to just get that and dose their water, it would be a way to go for it. And then the second is there a way to readjust the CECs? Because I think, as you said, we designed them to treat the disease without thinking about what next after it has been excreted into the environment. So is there a way to redesign them so that they are properly degraded within the body, or they are degraded by microbes or other microorganisms in the environment without us introducing a possible degrading agent? Thank you.
Okay.
Hello, I'm here.
Okay, yes. Professor Kenga, nice.
Okay, may I take this opportunity to thank Professor Christoph for availing himself to attend this conference that is organized by the Department of Chemistry, and also giving a keynote speech on this important aspect of water purification. Indeed, a lot has been done on this, the issue of water purification, especially in the African continent. And what has been found to be the major source of contaminants that cause diseases to most of the children and even the grown-ups in Africa. My comment would be to encourage the collaboration that is going on between Professor Christoph and the department. However, in Kenya, we got recently in Turkana County, there was a discovery of a mass of water underground. You know, Turkana County is very dry, and we felt really now we have a solution for that county to can participate in agriculture and water view using the underground water that had been discovered. But in the end, when the analysis was done, it was found that the water was contaminated. It was not fit for even human consumption or for use or for other purposes. I will urge Christoph and his team to come up with proposals on how such water can be purified so that it can benefit the communities that are really lacking water. You've heard of in Kenya, we are having tribal clashes related to their natural resources, one of them being water. Thank you, Professor Christoph, and I look forward to interacting with you further.
Okay, thank you, Professor. Maybe Professor, I take on some comments and maybe some questions. Maybe you could handle those ones, and then we'll take the next set later.
Okay. Thank you for the considerations and the comments and the reflections. I will try to bundle it. First of all, I must say that, like I said earlier in the beginning, that indeed the work that we are on CECs and the work that I presented here, certainly the second part was from a European perspective. But we did together, and if I mean together, I mean the team here, but also the team from University of Eldoret. We did quite a lot of work already in the past on looking for solutions on the local level, let's say. And that's where the projects where Professor Okot was referring to, and also the VC was referring to, come into the picture. And I must say I'm very grateful for the fact that we can collaborate in such a way already for years. I feel a lot of motivation from both sides, and indeed it is very pleasant to see growing up young people learning, let's say the background, the framework and the techniques to deal with this big environmental challenge. At this moment in our lab, we have indeed Philippe Massimi, a master student from University of Eldoret, and this week also Dr. Kenneth Correge is in the lab. Kenneth was actually the guy through which our collaboration started about 10 years ago, because he was doing a master study at Ghent University, and then we get into contact with some courses, and we were defining a master thesis topic for Kenneth. And that was actually the start, because Kenneth went back to the home country, to Kenya, to collect some samples. And the samples were brought to Ghent to analyze and to interpret together the data. And I think this ended up in a publication in 2012 somewhere. And to be honest, I think it was one of the first publications about the occurrence of pharmaceuticals in the Kenyan aquatic environment. It is only through this combined efforts from both sides that we indeed can progress in this field. And well, I think it is a very learnful experience for many of us. And I only can say that I accept the invitation to go further together. And that's also why we are preparing now indeed a new proposal. We hope it will be funded, and that should allow us to continue our efforts. So I would particularly like to thank all people that have been involved and that make this collaboration possible at different levels. I chose specifically to not include too much results of our collaboration on Kenyan waters in this presentation, because I was told, and I'm aware from the book of abstracts and the program, that there are two other contributions in this conference. There was one yesterday, I think, from Faith Chibir about pharmaceuticals monitoring in Kenyan waters and the Ati River Basin. And I think later on today, there is a second presentation of Philippe Massimi. Both students are heavily involved in our ongoing project. So this is to give some broader context on our collaboration, to express my gratitude and to express it also my hope that indeed we can further do that. Then to come back more on the specific questions that were raised, and I'm sorry, but I forgot the name. The names are not always easy for us to keep in mind. But I remember there was a question on how to use this ozonation techniques, for example, in your local context. Well, once again, I must say, this is a technology which is in development and which starts to be implemented in some European countries. But we should be aware of the fact that this is mainly used for centralized water treatment plants at a large scale, where indeed you can set up technological solutions, and where you can set up technical devices to create and to dose this ozone and or PMS into the water. Ozone PMS is still at the research scale, so I'm not aware of the fact that this is used already in real practice. Ozonation starts to be implemented. Well, it has been implemented already for a long time for drinking water production, but the implementation for wastewater treatment is much more recent. Switzerland is one of the countries in Europe which is running forward in this field, but also in Belgium, now we are looking to install an ozonation plant at full scale at a wastewater treatment plant. But to make the translation to the local situation in Kenya, which you know much better than I do, but at least through the collaboration I have some notes of it. I think this is not the solution that can be used at the household level. This is not what we call a point of use technology. No, there is no kind of a dosing system, a kind of a tablet which you can bring into the water and that will generate ozone or hydroxy radicals or sulfate radicals. I think for I'm aware of the fact that indeed there is much of direct consumption of water resources, groundwater or even river water. We have seen now that indeed we can expect that pharmaceuticals are present in that water, and not only pharmaceuticals, but also other contaminants of emerging concern. So if we look for solutions, we have for this local situation, we have to look for other solutions than the ozone-based solutions that are presented today. And indeed, like Professor Okot already explained, then we are working to the development of effective but also low-cost techniques that we hope to develop in the coming years, and that it can be used at the household level, at the point of use level. So this is also the way forward. I think that we should further explore to tackle the challenge that was bringing onto board by Professor Kinga. So indeed, if we see this kind of new water resources, which is a good point, because in terms of water availability, but on the other hand, the quality indeed is a big challenge. And we hope that, for example, with these bioabsorption techniques, that we can provide at least part of the solution. What we have seen in the studies that we have done together is that we see different patterns of contaminants of emergent concern in, for example, Kenyan waters, European waters, because of different. Yeah, there was a problem with the sound, I guess, because I hit myself 2 or 3 times. Yeah, no, it's better. We see different patterns and because of different consumption patterns as well. So this is reflected in the environment. And we see also that most probably the most vulnerable section of the population will be those people that have not access to quite clean water, but that indeed, for example, in the rural environments or in informal settlements, that have to deal with the direct consumption of often water. So we really hope that we can contribute to make forward some solution there. And then the last point, there was the suggestion, or at least the question, what about the design of these pharmaceuticals, for example? And this is indeed a good point, because now we are talking about solutions, but solutions at the end of the train. Solutions once the environment is contaminated. Starting from our awareness about environmental occurrence and effects of all what we have talked about today, I think the first reflection that we all should make is that we should try to avoid contamination as much as possible. And that can be done at different levels. That can indeed be done at the production level, because let's be honest, we cannot live in a world anymore without any medicines. We should be grateful that we have access to these medicines. But indeed, and this is also something which is going on, one is looking for more sustainable, environmental friendly production processes in the sense of indeed like biodegradability of compounds. How can we apply that for synthesizing new chemicals in the future? So this is certainly a good point to bring in, and if society, if industry could make chemicals with the same curing effect, but with less environmental harm, this is certainly a way forward. Secondly, I think we also not just have to look at industry and at production processes, but that we should also look at ourselves, at society in general, and that's like it was also already pointed by Professor Okot, that one of the things that we should be aware of the fact is that if we dispose residues of unused medicals or whatever, unused pesticides, unused sprays just in our environment, that it ends up in our waters and that it brings effects and risks with us. So we should be aware of that, and we should try to change as much as possible our attitude in the way how we use and how we deal with this kind of contaminant chemicals, so that they may not become an environmental contaminant. And I think this is a responsibility of society in general, because we have to tackle these problems at different levels. First point is to be preventive, to avoid the contamination by our attitude, by the way we use these chemicals, by new production processes. But most probably we will not be able to avoid any contamination. So we also have to work at the end of the process to find technological solutions to improve the quality of water, also regarding this kind of pollutants. So these are my reflections on what has been brought into the discussion. Thank you.
There's a comment on the side chat. Somebody is asking, Vivian Tuwei is asking, what is the outlook in taking the ozone-based technique in a scaled-up setup, such as large-scale water treatment?
Well, like I told, so in the Western countries, we are starting scaling up. A lot of work has been done on lab scale. A lot of pilot projects have run, and I think the technology is mature to use at full scale. That's also the situation in Belgium, where indeed we will starting implementing such a full-scale ozonation plant. The challenge will be the optimal operation in real condition. And so we are looking for effective ways on how to monitor and control in an as efficient way as possible the ozonation process. Also in point of view that the ozone dose, the amount of ozone that we add in water, this is a challenge because the water quality is not always constant. It fluctuates during the day, over the days, and we should be able to have a monitoring tool, let's say, to define the right ozone dose at each moment in the water. And therefore, we are developing techniques also based on online spectral measurements. This is also work which is done in my lab together with some colleague from me from Ghent University to develop this kind of online control systems. But this is important because it affects the cost. The less ozone you have to dose, the less expensive the process is. But also in terms of reactivity, because if you dose too much ozone, you do not only degrade the micropollutants, but you can also have unwanted side reactions, bringing some other challenges with us, what we should avoid, of course. Thank you.
Okay, thank you. Christoph, any other comment? I'm sure we shall continue engaging. In fact, I've just consulted with the head of department, and we are in the plan of maybe organizing so that you give us just a talk on what we've been doing and also include some data. So this one will be done later. I think because of time, we'll continue engaging through email or other contacts. I'll just like us to take this opportunity to thank our speaker, Professor Christoph, for his time to prepare the presentation and also accepting to come in and talk as a keynote speaker. We have really gained a lot from the talk, and as we've been told, it's a chance for collaboration and networking, which we believe is ongoing. So let's just appreciate Christoph. Thank you. Thank you very much. I think we could now stop there for the second session. In the afternoon, we plan to have a keynote speaker who will talk to us I don't want to preempt the topic. There's a chair will do that part. So I'm just requesting we break strictly for 45 minutes, and at exactly 2 o'clock, let us join this room for the keynote speaker number 3 for the day. Thank you, and thank you very much. You can make announcements.
Very much. Ladies and gentlemen, we want to apologize for the delay to start this session, the afternoon session in day 2 of our conference. This afternoon, we have yet another keynote speaker who is going to speak to us. And this is Professor Lusweti Kitui. I just want to read an introduction for him, and then we will bring Prof on board to speak to us. This is our keynote speaker number 5, because we already had 2 in the morning, although in the booklet it shows number 4. And the topic is innovative water treatment techniques in enhancing rural development. As I said, the speaker is Professor John Kitui Lusweti, B.Ed, UON, MSc, KU, PhD, Moi University. Professor John Lusweti Kitui is a professor of physical chemistry in the Department of Chemistry and Biochemistry at the University of Eldoret. He holds a Bachelor's of Education degree from University of Nairobi, which he acquired in 1981, an MSc degree in chemistry from Kenyatta University, which he acquired in 1986. And a doctorate, Doctor of Philosophy in Physical Chemistry from Moi University, which he acquired in 2001. His thesis title for the PhD was Investigation of Heavy Metal Speciation in Lake Nakuru. Professor Kitui joined Moi University as a tutorial fellow in the Department of Chemistry, and he was promoted to the status of a lecturer in 1992. 8 years later, he rose to become a senior lecturer to the senior lecturer scale, and soon after secured a Commonwealth Fellowship at the University of Plymouth in the UK in the same year, and that was for 6 months. He became an associate professor in the year 2012 at Chepkoilel University College, which later was chartered to full university status of University of Eldoret in the year 2013. He was inaugurated into the position of full professor of physical chemistry in the year 2018. Professor Kitui's research area leans towards applied chemistry, water pollution, and use of natural products and synthesized complexes in bioremediation of environmental matrices. Professionally, he has a wealth of experience and an incomparable many years record of postgraduate supervision. He has so far published more than 63 articles in refereed journals, 2 book chapters, and supervised to graduation 11 PhD and 34 MSc students. He has also examined 8 external and 3 internal PhD theses, 24 internal and 12 external MSc theses. He's an external examiner for 2 public universities in Kenya. He has held various leadership positions in the University of Eldoret, starting off as a warden, then head of a department in the Department of Chemistry and Biochemistry, and he has been a member of the Committee of Professors. He's still a member of the Committee of the Professors at the University of Eldoret. He has also been the chairman, board of management of several schools, and is actively involved in church leadership. Professor John Lusweti Kitui is married to Pamela Rebecca Musiche, and together they are blessed with the 5 children and 11 grandchildren. That is Professor Kitui, who is our keynote speaker this afternoon. It is now my humble duty to invite Prof to be able to give us his keynote speech. To you, Professor Lusweti, welcome.
Thank you very much, Dr. Wambu, for hearing. I've had.
Is Professor able to get us?
Yes, I'm getting you.
Yes, unmute him, please.
Are you getting me? Are you able to get me? Are you getting me? Hello? Hello?
Prof, if you can unmute from where you are, because we are not able to get you.
Oh.
Oh. Okay.
So it's unmuted, yeah.
Hello? 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 Dr. Wambu? Can you hear me?
We hear you. You can proceed.
So you can hear me?
Yes, we hear you. Proceed.
Thank you. Thank you very much, Dr. Wambu, for that elaborate and encouraging statement. The words you have read, they have encouraged me. Good afternoon, everybody, my listeners. This afternoon, I'm really privileged and grateful that I'm presenting on innovative water treatment techniques in enhancing rural development. And I will talk mostly on plant materials that have been used in treating water. An overview I'll present by looking at an introduction. We'll also look at the causes of water pollution, the effects of water pollution, the heavy metal pollution, control of water pollution, approaches to water treatment, heavy metal biosorption, then conclusions and future plans. The earth is known to be covered almost by water. It's only a third that is land. However, because of population increase and many activities that take place, there is quite a problem arising from pollution, which has reduced the quality. And it's not very easy that we get clean water especially in Africa and dry season. The plate which is there is showing people that in rural areas rely on surface water. And here the girls are trying to fetch water from the ocean. Also people depend on surface water. And this is a plate of River Nzoia. And people are drawing water from the shores of the river. We see a situation where a man is trying to drink directly from surface water in a river. That is still River Nzoia. We also have animals taking water, drinking water from River Nzoia. It is known that only about 37% of Kenyans had access to sufficient and safe drinking water. That is the Kenya Information Guide of 2010. The WHO Lives of 2022 reports that 2 billion people globally do not have access to clean and safe drinking water. Further, 3.4 million people die each year because of scarcity of water, and most of the water sources are contaminated. And in this case, or these cases, you'll find women, mostly, and children spending several hours, 3 to 6 hours every day. And what they do is just to go and collect water. In rural setup, you'll also find access to clean water depends mostly from NGOs, possibly drilling a well for them. Also, there are millions of especially schools and communities who do not have access to these NGOs or local government support. So here, before you, I want us just to show you some slides of water collection scenes. Here we see women carrying water, and one of them is having a baby, and possibly she's pregnant. So you can see women playing a very big role in that case. And so they cannot do anything else. We see a boy also carrying water, possibly has walked quite a distance to collect water. And that is what we see in rural areas. So in Kenya, many people do not get safe water for domestic use, especially those in rural areas. Some sources of water, mostly spring wells, boreholes, rivers, dry up, literally. You will find some rivers have no water at all. So when we have such like a dry spell, then people will queue up to get some water. And that's what we see. The jerrycans are arranged depending on who came early. This is a water vendor supplier. Here we have a well, no, not a well, yes, a spring well. Again, jerrycans. Actually, if you go to the rural areas, that's what you'll find. So the concern here is this, that a lot of time is spent because people have to walk several kilometers or miles. And here it is estimated that on average, even some walk 3.7 miles to get clean water. Now this time is spent on walking to get water or queuing. And it means therefore that no income is generated. If there are women, they are away They can't do anything else. If they are working, you can imagine now, if they have to go for water for a long distance, then when will they get time to do their work? So the economic growth here is affected in a way. Children away from school, if one walks such a long distance to get water, then when will such a child attend classes? The World Bank has warned that lack of clean water is an impediment actually to economic growth of a country by a third. So that is why providing clean water is key. It will help people concentrate now. Instead of looking for the clean water, they will now concentrate on other economic issues that will help the growth of the rural areas. So more than half of Kenya's population only have access to unsafe drinking water. And you will see many of them are getting from shallow ponds, shallow wells, and rivers. But when it rains, immediately the floods cause destruction. People are killed, houses are destroyed, and so on. So we see a case we had in West Pokot, flooded area because it had rained. This becomes like a river. And then you will find many of these people in rural areas, they are sick. They suffer from diseases associated with lack of access to clean water. Women especially and children who are subjected to collecting water also will have to endure possibly a malaria, drop out of school. They could be injured. Some even walk through bushes, and others get injured. Others get raped. Others become mothers at a very early age. So you find a big problem there. So Kenya's water and sanitation crisis, with a population of over 47 million, it is only by research revealing that 41% of Kenyans still rely on an improved water sources. And so we find shallow ponds, shallow wells. And you see like this lady is collecting water from just the surface of the ground. And this water, you can't believe, some of it will be used for drinking. We see a shallow well here, a pond. Someone is collecting the water there with a jerrycan. We see others bathing in the River Nzoia and other rivers. Now, what are the causes of water pollution? On 27th August 2019, it was reported by NEMA that by Nation Media, that NEMA shut down 4 factories which were emptying effluents into River Nairobi because these factories didn't have efficient wastewater treatment plants. So the NEMA also visited Chloride Exide Company and told them to do a few things. But later, it was reported that the Nairobi River was suffocating with a cocktail of raw and treated sewage from everywhere, including those poach estates in Nairobi. So NEMA shut down those companies, and of course, they are listed there. This is just a picture that was shown, had been aired by National Media Group. You see it's quite polluted, colored, and that is what you see if you went to Nairobi River. So we have metals we call heavy metals lead, for example, cadmium, mercury, and they are still used. Fertilizers, agricultural activities, and when these components get to the ground or to the soil or grass, and when it rains, it washes the chemicals into the ground or surface waters. And fertilizers eventually cause algal blooms. Other types, chimneys, smokestacks, which release chemicals. We have sewage and industrial activities. When also they are washed down by the rains, we find that toxicity or the toxic nature of these effluents become quite pronounced because of possibly the PCBs, and water therefore will be polluted. Even radioactive wastes, oil pollutions, plastics, and all these may result in invasive or alien species such as water hyacinth, very stubborn in Lake Victoria, for example, sedimentation. And so when these pollutants such as heavy metals find their way into the aquatic system or in the environment, they are washed down to the drains by rainwater and runoffs. They will be deposited in surface water, which is being taken by people and gets into rivers and sediments. You can imagine even what will happen to the fish and all those other lives that exist in water. So communities rely on surface water, as the pictures have shown. What are briefly the effects of water pollution? We find that people's lives, their quality will be affected. We have a system here showing water hyacinth covering water of Lake Victoria as an example. This will block the gills of fish, motoring, and moving on the surface of water by fishermen using boats will have a problem, and so on. Heavy metals also get exposed to aquatic ecosystems by the food chain. Animals, like we saw, taking water, drinking water in the rivers, may also consume such water containing heavy metals. Plants may also take up heavy metals. Grass will be contaminated. Heavy metals may also accumulate in both tissues of animals. And when man eats the animals, he also gets a problem. Lead is known to be cancer causing, and some of the effects are known. So the problem now is metals. They do not break down. They are not biodegradable. So once they have been taken into the body system, they can't break down, and that's the problem. So they are persistent, they are toxic, they are bioaccumulate and threaten human life. We have an example that happened in Mombasa, where there was a problem with lead poisoning in there's an estate there, and KTN captured that, and you can see the leg of this person. That's a big problem. Now the issue is, how do we control water pollution? The World Bank reported in the Invisible Water Crisis and remarked that a combination of bacteria, sewage, chemicals, and plastics can suck oxygen from water supplies and transform water into poison for man and the ecosystem. And it also reported that about 1,000 new chemicals get into the environment every year, and 80% of the world's wastewater is released without treatment. The fertilizers, about 30 to 50% of the nitrogen applied to soils leaches into water, air, and so on. Aquatic life is suffocated, and this is also affecting worsening the climate change and shortening lives through contamination. So unless the government comes up very clearly on punishing the culprits and forcing the culprits with heavy fines and forcing them to clean the affected environment, this may be a problem. But key thing is that the public should be made aware of that, of pollution. So therefore, this afternoon, I'm asking that following what we've seen, people drawing water for domestic use in jerry cans, whether from rivers, whether from boreholes or wells, what would then be the methods suitable for rural water treatment? That is a key question. Another question is, what techniques would be used that would be affordable? Then how reliable and accurate are such techniques? And what would be the environmental considerations? So one way possibly is to drill water in rural areas, but drilling water is expensive, just like you can see here. It requires land, and unless it is sponsored, the government doesn't have enough resources to drill water for families or for people in rural areas. With that, therefore, there has been a search for water treatment for many years. And the water treatment methods should be suitable, cheap, efficient, and clean to the environment. And so natural water products, natural products have been fronted, and a lot of work is being done, has been done, and there seems to be promising and hope relying on the natural products. And so because they meet the criteria as good biosolvents, they are not pollutants, and so on. And so following that, we took time now to carry out research basing on natural products. And the most common have been the plant materials, the brown algae, green algae. We've also used the moringa. These are the pods for the seeds. On the moringa and algae, I've had students graduate with their PhDs. We also have arrowroots. Student graduated with a PhD, arrowroots, waste tea. The waste tea leaves. Someone also graduated with a master's after working on that. So the main issue, therefore, is that the natural products are they are quite convenient. You are not left with the environmentally unfriendly materials because they decay. So natural products are quite convenient because the normal methods used, like what we use in water treatment plants, those methods are expensive. Sometimes they cannot adequately treat water because of increased populations and so on. Also, when solutions are very dilute. So biosorption, therefore, which is just binding of the ions, can also remove those ions or heavy metals from aqueous solutions. They are cheap, and this can be used, and that's what I'm trying to propose, that if this can be taken up, then we can be able to reach out to the rural areas where water is taken without even minding on the pollution aspect. So heavy metals can innovatively be removed by utilizing dead biomass, which are very good at taking up the heavy metals. And we have a simple mechanism. A biomass can be, on the surface, could have groups like the carboxyl. And then when you add a metal, it is complexed with release of hydrogen ion. So the work involved 4 different materials, algae, both brown and green, the moringa, oleifera, fera, the arrowroots, and waste tea leaves. The parameters, we looked at particle size, what is being reported. There are other parameters, but I'm only trying to give what I'm reporting here. Contact time, pH, and stirring. The equipment we have used involve, among others, ICP-OES, ICP-MS, AS, FTIR, and the FAS. This is the equipment ICP-OES, and it's me here using this equipment when I had a chance to go to University of Plymouth in England. Very, very big machine, it's bigger than the AS. Some of the results, we see that the concentration against pH shows that cadmium is the most biosorbed, followed by zinc, and then copper, and then lead is the least. Of course, at lower pH, the concentration or the amounts released biosorbed are a bit lower, and pH 5 seems to be the most optimum. At higher pH, the amounts biosorbed in the 4 metal ions we see seems to be quite low again. Reasons, of course, at low pH, cell walls, wall ligands are associated with the hydroxonium ions. The metal ions get access to the ligands, and then carboxyl groups are exposed, and that will lead to attraction to the negative ions and the metals. So we find the biosorption is high. And then, of course, biosorption, in this case, is surface, is quite on the surface. And the 4 metals, of course, were biosorbed less at lower pH, and that agrees with what had been done earlier. At much lower pH, the cell wall ligands will associate with the hydroxonium ion, and that will restrict the access of the metal ions to the ligands. But when the pH is very much increased, biosorption for the metals, of course, again, will be affected, it is lowered. So that's what we see happening. Also, there would be competition, hydroxonium ion and metal ions. So at low pH, because hydroxonium ion is positive, its concentration will be much higher than that of the metal. So it will be the one preferred. It will be the one occupying the binding sites. And that will leave the metals unbound. And that's why at low pH, there is a reduction in metal bioabsorption. But when pH was increased, the competing hydroxonium ion decreases. And so the positive metals, they take up the binding space. And so we find, again, a change in the bioabsorption. So in short, I want to say that from our studies, at low pH in non-complexing aqueous medium, cadmium was the most bioabsorbed metal because it existed as cadmium ions. And the order of bioabsorption followed that as cadmium more bioabsorbed than zinc, more bioabsorbed than copper, more bioabsorbed than lead. But at high pH, a metal such as copper will exist in the insoluble oxide form and hydroxyl form, which is precipitate. And the larger cations like lead will be most naked. The surface of lead, because it's a big ion, it will be least hydrated. So it can easily be bioabsorbed. And the order still is given now, in this case, at pH 6, is cadmium, copper, then zinc, and lead. pH 5 was found to be the optimum pH, although some books, some literature give pH 6. We also had particle size, and I want just to report here that the size of the biosorbent really contributed to this, and with the size being less than 1 millimeter at pH 5 and 9, the order for the algae zinc was more bioabsorbed than copper, than lead, cadmium, which was more than for lead. And at pH 9, there was a change a bit. Zinc, then cadmium, then copper and lead. So what I'm saying here, the size of the particles, the biosorbent also we found it is important, and that agrees with what has been done. When we reduce the size, we also change a bit the order. So that's what we see. This is just showing the effect of contact time on removal of ions at pH 5. So you see that this is cadmium, then this is copper, then lead again is the least, and then we have this as zinc. So I don't want to get into details. So I want also to say bioabsorption of heavy metals in the stirred system followed this order. This is zinc, most bioabsorbed. Then we have cadmium. Then of course lead, the least, again with the same points. So what I want still to ask is, what must be done? Of course, the studies which we have done, we have tried to work on the pH, we have worked on particle size. Now the adsorption isotherms, just to report on algae alone, is what the table is giving. The R squared, basing on that equation for first order kinetic model, and K1, then second order is T over Q, the amount absorbed, and K, the constant. So you can just have a look here that R squared values for first order, they are generally, other than this and that, they are smaller for second order. So that then means that the algae biosorbed these ions basing on more predominantly the second order kinetic model. So that we are saying that although the first order model, kinetic model also was followed, but majorly was second order. And that's what we are saying. Generally for first order, the values were low, and that is also reported. Adsorption on moringa, similar thing. For first order, they are smaller than for second order. And so again, the metals were biosorbed by majorly mechanism of second order kinetics. So in conclusion, therefore, is that these materials which we have used, it has been proved that they are good at sucking or at biosorbing or removing heavy metal ions from water. Because of time, I would not report values on like arrowroots or waste tea, but I've just looked at algae and moringa. Also, metal uptake capacity increased with time, but it reached equilibrium after some time. Particle size and pH affected metal biosorption. And so the results also proved that pH determined the metal biosorption, but the optimum pH was between 4 and 6. But mostly the optimum pH was 5 and 4. Different particle sizes gave different biosorption abilities on different metals, hence the order. But generally, the larger fraction of pore size offered better biosorption, possibly because the smaller pore size, the smaller size of absorbent could lead to blocking, and because they are very small, although the surface area increases, but again, the surface groups may not be easily be veiled because of very fine material. And then biosorption mostly also followed the Langma more than the Friedrich. The future prospects, we intend to inform the public on the danger of water pollution. Even as they draw water and use it domestically, they need to know that water is polluted. That is one thing. The other thing, we shall also tell them that there are ways of trying to treat the water. Now, we can not use the methods that are used to treat water, large volumes of water, like in the municipalities, because these are people who get water from boreholes, maybe in the homes, They also get water from rivers or get water on the surface. So they will need, therefore, to be empowered, to be helped to treat the water they are taking from those sources. And so we confront very proudly the plant materials which we have used before, the moringa or ephera, the arrow roots. And the advantage of this is that they can be, we can plant trees, they can offer as firewood, as sources of energy, but the moringa is also very useful, even biofuel can be gotten from there, but the plant is medicinal. It has medicinal values, nutritive values, so there are advantages of growing moringa tree or ephera. And the tree grows even in our place here in Eldoret, Western, everywhere. The arrow roots, other than being used for water treatment, they can also be a source for the carbohydrates. They are very good. Many people like them as a source of carbohydrates. So we can try these methods and we can't lose anything. Then have a way of harvesting the algae from the Indian Ocean and processing. These are processes which are not very expensive. Then partner with manufacturing companies for domestic water treatment gadgets. So if we can have materials made into powder, and then we make possibly as filters and all this, the homes, families can be given these gadgets so that they can be able to treat the water before they take. Otherwise, before the situation gets worse, it is important that something is done. And that's why I have taken it upon myself to see if we are to recommend this for water treatment in rural areas, then what can be done? So we've seen we can get into manufacturing so that we have many of these gadgets to help people at least have their water treated in their homes, not relying or not waiting for sponsors, not waiting for the government to bring treated water. And this will help, it will help even the growth of our economy in rural areas so that people don't spend too much time to go and fetch for water, but they will now concentrate on economic growth of our rural areas, which affects the economic growth of our country. Acknowledgements to God. I also acknowledge all of you for listening to me. I also want to thank the conference working team for giving me an opportunity to share my findings. Dr. Mike Fox and Professor Paul Worsfold, University of Plymouth, and even Andrew Fisher for technical support. Professor Gajanja of JKUAT, who supplied the moringa seeds. My colleagues in the department, Bishop George, Dr. George Kijana for inspiration, and my family for love and support. Thank you very much, and God bless you. See there. I wanted to unmute.
Very good talk. I hope I'm okay. Thank you. I will now open the floor for any comments. Any comments from the floor? I have got some here with me. I have 3 questions. Somebody sent me these questions. The first one is this person wants to understand, does the interaction of algae or moringa with water affect water quality, in that other ions were also removed from the water besides the heavy metals? Then number 2, that did you extract individual compounds in the algae or in the moringa that were responsible for biosorption, or you just used the crude extracts? Then another question is, in your studies, did you consider the speciation, metal speciation in the pH range of your experiments? Because the metals, I think was trying to say that the metals, the dominant speciation are pH dependent. So did you take into account the possible dominant metal species during the adsorption process? Maybe, Prof, you can address those ones as we see if we get others. Thank you. Thank you.
Yes. Yes. Thank you, Dr. Wambu, for those questions. Indeed, there are many metal ions that are involved, and the study could not have looked at all of them. We were using a few to study the interaction. And so we did not look at interfering species. Indeed, when you have zinc, for example, and copper and iron, lead, there are specific ions that interfere with that. We did not look at those details, but however, this can be done, and that's why research is still going on to find which other interfering species, how can they be tamed before this. But the important thing is that the major and known ions, which are found generally in levels that are of great concern, is what we are looking at. The question 2, individual compounds extracted, no, we did not go that way. But yes, if this can be done, extraction can be done, and then possibly manufactured or synthesized. But we didn't want to go that way because synthesis involves pollutants, involves other compounds formed. So we were looking at the plant materials in their totality and what they can be done. Like when we are talking of waste tea, it's just after extracting, getting tea from the tea leaves, and then you sieve and you dry these tea leaves. So we were trying to look at what is considered possibly as waste ending up being very useful. Hence, you don't spend much, but work is still going on. And then we did not look at metal speciation, the pH range, because what we did, first of all, was look at which pH was most suitable. Then after getting the most suitable pH, then we carry out biosorption studies at that optimum pH. So that's what we did. But I know, yes, this can also be done, the speciation, the different species of each ion, when they get into the surface or to the surface of the material, which species of zinc is most likely to be desorbed or biosorbed than which one. So that is also another study. And I want to say that actually, whoever has asked here is also agreeing with me that there's still a lot of work to be done on this. Thank you.
See, there is a hand. I think it is Joshua. Joshua Kemei. And then I think there is a general question in the chats. Dr. Tway, I want to get that chat. Yes, meanwhile, let Joshua ask his question.
Thank you, Prof, for that wonderful presentation. I just want to seek clarification. You talked about the carboxylic functional group, which is actually on the surface of the materials you are using for biosorption. But I suppose most plant materials have, or they actually made up of carbohydrates, where they have mainly the hydroxyl functional groups. Yeah, because I suppose when you talk about the algae and the plants, their major components are actually polysaccharides, which are carbohydrates. So does these hydroxyl groups also play a role in the biosorption? Then number two is how realistic is the use of these plants, like the arrowroots? Yeah. Actually, with the fact that we know that's actually a food material, and how could actually the rural people take it? Yeah, either for treatment or as a food material. And then for the algae, which type of algae species did you use in your study?
Yes, I've gotten them. Thank you, Kemei. The carboxyl or the carboxylic acid group was used as an illustration. But the studies as was done earlier on by the FTIR is true, gives other functional groups, the OH, even the NH, all those groups were there. So this was an example, but it was not saying, the equation was not saying that that is the only functional group available. There are in fact many, and we also modified these functional groups and saw the changes effected, which compounds are best at modifying the groups available. So that's why we used other equipment to identify the kind of groups available. The other thing on food material, yes, the arrowroots, you know, when you are preparing the arrowroots, you remove the top, you like potatoes and even cassava, the husk, the top. So you can use that instead of throwing that. That can be the material dried, ground, and used in biosorption. So the aim is that, yes, we have certain materials used as foodstuffs, but they are remaining, just like wheat husks can also are very good materials for biosorption. So we are trying to look at any material that you may think is a waste, can be put to use to help society, to save man from pollution. The algae we have, maybe it escaped you. We have the brown algae and the green algae. The brown algae, very, very common at the coastal ocean, and the green, they are very common also on rocks and so on. So these are wasted materials. And then, so that is what we used. I even didn't report here, but it was found the brown algae to be more it's a better biosolvent than the green, but they are all, they are useful. Thank you. Chair, I don't know if you talked of general question. Yes.
So I will allow him to, then Professor Ruta, then Professor Koth. Professor Ruta, come first.
Okay, thank you, Dr. Wambu, the chair. Thank you, Professor Lutreti, for the talk. I just have two quick questions. Number one is the sustainability of this material in cleaning water. Do you think we have enough so that it can be extended for large-scale cleaning of wastewater? Number two, I would want to know, you are focusing mainly on heavy metals, but we know we have other contaminants that can affect water. Do you think the same can be removed, can be used to remove other contaminants? And then number three, vis-a-vis the cost, have we tried to compare the cost of what is used to clean water versus the materials that we are using? Because we might say it's cheap, but the process of preparing the materials could bring a challenge. Thank you.
His questions, and then you take all of them. Remember also, Dr. Tway was asking if there are any challenges and limitations associated with this scope of research. So you will combine that, Dr. Tway's question about limitations and challenges, then Professor Luta's, then Professor Koth.
Thank you. I hope you can hear me, Professor Lusweti.
Yes, I'm hearing you, sir.
Yes, I was just interested in the mechanism of the biosorption, because different materials that are being used as biosorbents have different mechanisms. For example, if we are talking about the peels of arrowroots, what kind of mechanism is being used or is being used for the elimination of what you do not want, like the heavy metals? Because some work through active sites and others work in, purely on physical means. So I just wanted to know if you have ventured in that area. Thank you.
Thank you again, Dr. Ambu. Yes, the challenges, let me answer that one maybe later. The sustainability of materials in cleaning water. Yes, because Prof is saying, how do we sustain? That's why was proposing that we encourage people, a serious campaign to plant, for example, the Moringa oleifera, because these are, although they are different species, but they are trees. So we can handle it from that angle. Maybe the forestry, the environment ministry can supply seedlings. I saw seedlings in Kakamega. And so give farmers to plant them, because they are trees, it's medicinal, they have medicinal values. So if we have enough, then it is possible that we can harvest them and do the processing. And even some don't need processing. Some communities use them as they are to make water clear, the tepid water clear. So that can be an approach. So when we have enough, I believe it can be sustainable. In terms of cost, yes, we are looking at, these are cheap materials. You can make timber out of Moringa oleifera because they can become big trees. We go medicinal, from the medicinal point of view. They can even, we can even get to the other area, get people like Dr. Barasa, we get even to start selling the medicine. So we definitely, they will not be costly compared to the cost involved in treating water by, say, the ministry or the municipal. And what is involved, energy, all that, the equipment. So we may not have done the cost, the real cost, but I look at it that it will be cheaper, definitely. On why only heavy metals is that the heavy metals are of greater concern. Yes, we have other ions, like should you have the nitrates, should you have the phosphates, those can also be looked at, but it is heavy metals that we are concentrating on because of the effects known. And because of that, as we said earlier, they are non-biodegradable. They will be a problem if people continue getting into that. But yes, there are other ions. We can expand this, use other systems to handle other ions and other compounds and other species. But this one is a kind of a jumpstart research to enlighten people, for people to know that there is a problem. Concerning Professor Okoth, yes, you have correctly said which mechanism. And that's why, even in my explanation, we were not just looking at one mechanism, but one mechanism could be through competition. The metal ions in solution will be like this one's positive 2 ions. Now the size matters, hydration matters. They could also, some of these materials have cavities. So the pore size also is very important. So it is not only the physical, but it could also be chemical. You form a bond, but generally it is known that it is not chemical. You form most likely a coordinate bond to the, like the carboxyl. or the OH group. So you replace hydrogen ion and you form a coordinate kind of bond. So the mechanisms are quite very, very elaborate, and some are very, very, very scientific, where you are looking at even the size of the complex formed. But generally, complexes are also formed in this case. So the mechanism is explained in the study, and I know I liked what you are saying when you talked of the ozone approach to this. In fact, I was saying it's good that we put the efforts together, because our approach is from the plants. You are approaching from a substance that will be used to do the treatment. And all this, I think, can make up a total study that can be very, very enlightening and also saving humanity. When it comes to what Dr. Tway said, the challenges and limitations, of course, this study has challenges so far. The first challenge is the equipment. We, of course, looking for like ICP OES. I had to do it because I was in the UK. I don't know whether we have one here. ICP, MS, ICP, OES. So that is one challenge. The other one, the limitation, of course, acceptability. When people come up with inventions, the total, the populace, the target group accepting may require time. Even our own research, because someone will tell you, like what one was telling you, your work is to do research. When you talk of possibly even patenting certain things, we are limited. So we are coming up with the innovations, but the limitation is the putting it to practice, because we are not the final people. But I can comfortably start applying this, because I know if it is moringa or leifira, I know that it is not poisonous, but someone else, even you yourself, Dr. Tway, to accept, it may take time. So that could be limitation. And then the other one, of course, which you already know, it requires resources, and because of limitation, that may make us not go very far. And then research also requires continuity. Continue doing the research. That is a challenge, but I believe that what we have started by having research groups, like what Professor Koth is done and Professor Luther, that can help us to be focused and remain on course, so that we continue every year improving. When we get new ideas, we continue into that. So in brief, that's what I would say. I hope Chairman been clear on those issues.
I don't know if there's still some questions from the audience. Looks like there's a chat. I can't read those, they are far. My computer went off. Maybe I ask one. It's off the battery. Prof, one of the challenges with the using the biomaterials is that the biomaterials degrade. In other words, they start to rot, and there's also the possibility of harboring microorganisms. So I do not know how in your study you are able to navigate this problem, because once you use the material, that material starts to biodegrade. So how were you able to control the biodegradation of the serpents? Then I think Joshua has got another question, and I think that will be the last one.
Yeah, thank you, Chair. Prof, I wanted just to know, have you tried to maybe develop a prototype equipment which you can actually use for water treatment? Because you can't actually use these materials alone. You must maybe have some small equipment, maybe like a water dispenser, which you can now say can actually be used to treat, especially the domestic water. And I think this is what is going to inform on the cost of this mechanism of water treatment.
Thank you, Dr. Wambu and Sakeme. Yes, the challenge with the biomaterials, yes, they decay, and that is why if put in a proper place, like a compost pit, they will decay. So the advantage. But of course, the other challenge is the material has biosorbed heavy metals, and you throw them in a compost pit. What we are saying is that that compost pit, when the biomaterial decays, to leave the ions, those heavy metals in there. That is a challenge, yes, on disposal. We are saying not much problem. And then you talked of harboring microorganisms. Yes, you may, or you may not, depending on the use. Yeah, but yes, those, I think that would be, I would say, a challenge or a limitation. But looking at what has been done, because what we have in mind is that you can get these biomaterials, and they could be like what we use, the iron material, what we use to make the water you dissolve the suspended solid materials, the alum, the aluminum material. So you could have that kind of thing. So this material is not a tree, but it could be in powder form, could be in a form that it will act as a filter. So then we can pick on the best form so that we avoid the challenge of biodegradability and microorganisms. But I would say those could be challenges. On the prototype equipment, yes, Sakeme, you are right. But for now, we wanted to establish the science and confirm that it can work, that yes, the issue is the pollution, and our people in rural areas are taking water the way it is. So someone goes, draws the water from the surface and simply filters using some cloth, some clean cloth. Yes, you get water which is clean, but it is not clean at all. It may be clear, but there are very dangerous ions in it. So that's what we want our people to know, because we are saying that without people changing their approach, the way they handle things due to poverty and ignorance, we may end up losing the society due to uncontrolled diseases like cancers due to heavy metals and these other pollutants. So yes, the gadget, that's why I use the term gadget, should be simple to operate, simple to use, cheap, and like you just insert in a container, maybe that drum or jerry can, and then you clean your water, you treat your water. That's what we are talking about. I saw in Ethiopia that they are ahead of us. They have gone ahead, of course, using certain filters, not plant materials, but they are ahead of us. So that's what we are looking at. And I agree with you, cheap equipment, simple is important to front it. Thank you.
I think with that, members, colleagues, we can stop there for today. The other rooms, I think they are going on. So we will close this session, and then we can join the other rooms from now. Thank you very much. Yeah, the
by antioxidants, human serum albumin, and hemopexin. Gradually, once the heme that was taken up by hemopexin has been cleared through endocytosis, what is stored by the lipoproteins is transiently transferred to human serum albumin and also the freed hemopexin. Gradual transfer imply then that the hemopexin will soon be free from heme, and what was in the reservoir, human serum albumin, is transferred to hemopexin. And so our argument was, if under normal circumstances, the heme is stored by hemoglobin, and if under pronounced hemolysis, the heme is stored by lipoproteins, human serum albumin, and hemopexin, what evidence do we have to select one of the three sets of proteins as the target? So we searched in literature and discovered that the binding affinity of hemopexin to heme is in the order of 10 to minus 12 molar, while that of hemopexin is 10 to around minus 12 molar, human serum albumin 10 to minus 8, and that of the complex, heptaglobin, hemoglobin complex is 10 to minus 23 molar. Evidently, the one with a weaker affinity is human serum albumin with 10 to minus 8 molar. And that informed our decision to pursue the human protein that harbors the heme, methhemalbumin. Next slide, please.
Dr. You have 3 more minutes, so please summarize.
Yes. If you can move the slides, I can. Okay, the methodology is shown here. EPO-HACCP, which is heme-free protein, was expressed, purified to homogeneity. Then lyophilized sample of human serum albumin was reconstituted with heme to form heme-loaded human serum albumin. Then the amount of heme incorporated was determined as pyridine hemoglobins. Heme transfer assays was performed, and then the transfers were evaluated using polyacrylamide gel electrophoresis. And the results show that you can, or one can spectroscopically monitor the transfer of heme from methhemalbumin to the HAS system, HAS-AP, using UVV's detector. In the second slide, which shows a superimposition, before this place, the second one here, which shows a superimposition, evidently you have a redshift of the Sorey from 404 to 407 nanometers with concomitant decay of the charge transfer bands at 500 and 535 nanometers. And that is indicative of transfer of heme from methhemalbumin to EPO, or the heme-free protein, as a function of time. We also have a charge transfer band shift from 623 to 618, and a growth of a charge transfer peak at 574 nanometers. Both are concomitant with accumulation of heme in the hemophore HAS-AP. In the next slide, we have a superimposition of the two. The protein that has been loaded with heme, now referred to as holo HAS-AP, with a tall intense peak, the reaction product in red, and methhemalbumin in blue. And this was taken after the experiment. To the right is the charge transfer or the longer wavelength side. So evidently, there is transfer of heme from the host protein methhemalbumin to the EPO protein HAS-AP. In the next slide, we then trace the growth of the Sorey band, which is characteristic of the growth of the HAS-AP peak at 400 nanometer, or around 4 or 7 nanometers, and also the growth of the peak at 280 nanometer, which is characteristic of a band. If you see between 40 and 50th fractions, you have 2 to 80 nanometer bands there. The initial one is for the methhemalbumin, and the second one is for albumin. Sorry, is for the HAS-AP. So again, this shows or demonstrates that indeed we have a transfer. This was further confirmed by running native and SDS gels. The next slide. This shows the rates at which the two were taking place. We have a growth at 574 and a decay 500, 535 and 618 as the heme changes positions from between the two proteins. And in the next slide, we have a native polyacrylamide gel at the top A and an SDS gel at the bottom B. In the native gel, we see the bands of human serum albumin, the uppermost. We have one band for apo-HACP, that is the protein that has not loaded the heme, and the holo-HACP, the protein that has loaded the heme. Have an intense
maybe just
sorry. Hello.
Yes, you're still a bit off.
Recording in progress.
Hello, Dr. Glagat, are you there? So I think there was a. Are you there?
Yeah, right there. So on the lower, as before this, the second class, yeah. So on the second page, which is SDS page, we see the HSA band clearly and the HAS-AP band clearly. So these ones evidently shows that we had a transfer. What I need to point out is we had a fourfold in excess of HSA compared to HAS-AP, just to be sure that we don't have limiting HSA in the transfer. So we concluded then that once the bacteria experiences ion limiting conditions, it targets methemalbumin as the host heme source to sequester the ion and uptake it for growth, colonization, and subsequent infection of the host cell. Now, the rate of heme release from methemalbumin, I didn't show the results here, correlates with the rate of heme uptake by apo-HACP. These rates are comparatively higher than the rates of heme uptake from the other host heme proteins, hemopexin, hemoglobin, and heptaglobin. However, the rates of these three proteins are comparable to the rate of dissociation of heme from methemalbumin in the absence of the hemophore. So these 2 points confirm that the target protein is methemalbumin. So there is room for further discussions and studies on this to demonstrate or to find out the mechanism of heme uptake by the human, by HACP from the human host protein methemalbumin. It has been demonstrated in vitro using heme transfer experiments in this study, and the way forward is to do it using the actual hemopexin, hemalbumin in vivo. Thank you.
Okay, thank you very much, Dr. Lagat, for your presentation. I apologize again for the small hitch that happened in the middle. I open now the floor for questions and comments. So you're free to make any questions or comments on the presentation. If you cannot comment directly, you can just post it in the chat and I'll communicate the same to Dr. Lagat.
Thank you.
So maybe as members are preparing their questions, maybe I can ask one.
Yes, please.
Maybe I just wanted to ask, because you selected to look at the heme uptake and the iron uptake by uriginosa, is this the key way in which it's able to sustain itself? Is it key to the survival of uriginosa in terms of infecting humans? So as to, yeah, continue.
Okay, now I would say it is not key, but it's a preferred for two reasons. Now, free iron, ferric iron, is very toxic, and it is stored by iron storage proteins such as ferritins, or it can be stored as iron sulfur clusters, and the two proteins have very high affinity for iron. So it's very, very hard for this protein, Pseudomonas aeruginosa, to extract free iron or iron from the two iron storage proteins. The other option is to target the heme iron, which is stored in the heme proteins. Now, there are three ways that can be sequestered. Either the protein under iron starving conditions can directly bind the heme or the host heme protein, and it binds via the outer membrane receptor directly. The other option is to engage the TON-B-dependent outer membrane receptor and a cognate accessory outer membrane lipoprotein. The third option would be secretion of the heme binding proteins, the hemophos, to the extracellular medium. Particularly, the last one, the hemophos system or the heme binding system, is what is employed by Pseudomonas aeruginosa. Other gram-negative bacteria can employ the first two, direct binding to the membrane, or the pipetted TON-B dependent. There are other types of bacteria that share the same pathway as Pseudomonas, and studies have shown that bacteria like Yersinia pestis, bacteria like Serratia marcescens or Yersinia pseudotuberculosis employ the secretion of small heme binding proteins. The reason being the high affinity that the iron binding proteins have towards iron, which could be easily accessible. So the heme iron pathway is preferred. I hope I've answered your question.
Thank you. Yes, you have.
Yes.
So I open the floor to other members to please ask some questions or make a comment.
I think Professor Luther's hand is up.
Hello, Dr. Bisem.
Yes.
Oh, this is Professor Luther. Can I make a comment?
Please proceed.
Hello?
Then after that, yes, Professor Luther, you can proceed. Then after that, Professor Lusweti. I can hear you.
Okay, thank you, Dr.
Yes,
Bisem.
please
Thank you,
proceed.
Dr. Lagat, for that talk, which is very informative on these bioinorganic molecules. I just wanted to ask a general question. Are there modifications that can be done on this hemoglobin to prevent them from attack by the pathogen that you are talking about. And how does it also affect the other bioinorganic molecules like myoglobin and hemoglobin? Or those are, or the talk is specific and can be extended to those kind of inorganic molecules. Thank you.
Okay. About modification, I didn't get it clear. You mean modification of the human serum albumin in vitro, in vivo, or modification of the HAS-AP? Sorry.
Yeah, the modification of the structure of the biomolecule.
The structure of the biomolecule. Yeah.
Yes.
The structure of the biomolecule. Now, what I've been able to do is modification of the bacterial protein, the HAS-AP, because that one I could manipulate in the lab. And the modifications that I made were replacing the histidine at position 32 to alanine. And so we created H32 mutant. And then we created tyrosine 75 to alanine mutant, tyrosine 75, sorry, histidine 75 to alanine 35 mutant. When we did all these modifications, it was evident that irrespective of whether the distal residue that binds the heme is present or not, the heme will still be bound by the protein using the proximal ligand, tyrosine 75. So the mutant still bound the heme. When we replaced the tyrosine at 75th position, which is the distal ligand, with alanine, the heme bound to the histidine 83, implying there is an alternative if you mutate the distal ligand. However, when the two distal ligands are mutated, the heme does not bind. So what that implied is the distal ligand, be it histidine at position 83 or tyrosine at position 75, once they are there, the heme will be bound. And it will trigger the closure of the loop. So the loop, which I mentioned earlier, that it's about 30 angstroms away, that loop will just close in, whether it has the histidine at position 32 or alanine at position 32, that loop will still close. So the secondary structure of the protein actually induces the closure. And that was demonstrated by modeling, simulation modelings that showed actually the movement of that loop from the upper position to the lower position. Now, as to whether we can modify the host cell heme protein, the human serum albumin, or not, that is something that can be done in future. However, we would like to have a scenario where we can mimic the actual human protein in the lab and see the behavior of the bacterial protein so that we can inhibit binding of the heme by the bacteria. I hope I've answered the first part of the question. Now for the second part of the, thank you. The second part is what happens with, did you say hemoglobin and myoglobin?
Yes.
Yes. Now, earlier on in my presentation, I gave the KD values of hemopexin and heptaglobin. We noticed that hemoglobin, hemopexin, and heptaglobin have a higher affinity for heme. So they bind heme more strongly than the human serum albumin. And the rate of heme release by human serum albumin correlate with the rate of heme uptake by the bacteria. On the contrary, the rate of heme release by the other three proteins is way slow because of the high affinity. So automatically the bacteria will go for the protein or the host protein that can have easier access of the ion because it's under ion starving conditions. And the operon actually that harbors that is upregulated in the bacteria. under ion starvation conditions. So it's the rates are in nanosecond, millisecond, just to say the least. I hope I've answered your question. If I haven't, you can ask further. Yeah.
Okay, thank you. Professor Lusweti, I was told you also had a question or a comment. Professor? Okay, then we'll end there. Thank you very much, Dr. Tari, for your presentation. We'll move on to our next presenter, which is Mr. Victor Shikuku. Just give me a second. So Mr. Victor Shikuku's presentation is titled Enhanced Performance of Hydrogen Peroxide Modified Pozzolan-Based Geopolymer for Abatement of Methylene Blue from Aqueous Medium Abstract. Victor, are you there?
Yes, I'm there. You can hear me?
Yes, so just give us 1 minute to, yes. So the floor is yours. Please proceed. You have 15 minutes.
Okay, thank you. I will take us back to matters on water pollution and water treatment. And we will be focusing on an emerging class of adsorbent, that is geopolymers, and how we can improve their textural properties to improve their performance as adsorbent. The next slide, please. So geopolymers are basically inorganic polymers. They can be obtained by reacting an aluminosilicate with either a strong alkali or an acid. The aluminosilicate material or the precursor can either be of a geologic origin, such as volcanic ash. It can be an industrial waste, even municipal solid waste incinerator, fly ash, for example. Geopolymers have a wide application. Primarily, in their origins, they were mainly applied as an alternative binder in replacement to Portland cement. But over time, they have been applied in different areas and recently as water treatment adsorbents. So next slide, please. So like any other adsorbent, geopolymers vary. Their performance vary both on the absorption conditions that will have to do with experimental conditions like the pH, temperature, the presence of competing ions, and so forth. And also their performance depends on their structural and textural characteristics. We are primarily interested in their structural and textural characteristics in this study, which are controlled by the nature of the precursor material and also the preparation conditions. And the preparation conditions include any modifications that can be done on the material itself. So the next slide, please. In terms of looking at how the textural properties vary with the preparation conditions and how this influence performance, recently also we published a paper where we had both acid and alkaline activated geopolymers using volcanic ash as the precursor material, and holding all the preparation conditions are identical except one is acid and alkali. We looked at the effect of this on their textural properties and how this also affects their performance for the uptake of both cationic and anionic dyes from water. So what we are demonstrating here is the effect of the preparation conditions on the textural properties of the material and how those textural properties are, influence the performance of the material on different molecules with different properties as well. So here we look at both the adsorbent properties and also at the adsorbate properties as well. Next slide, please. Again, apart from the preparation conditions, in this other article, we also indicate the effect of the precursor material on the textual properties and also the performance. Here, we were having the precursor materials as a blend of volcanic ash and metakaolin. And so as you replace the volcanic ash with metakaolin, we notice that the textural properties, in this case, the surface areas will improve. But the interesting point was that though the surface areas were increasing, the absorption capacity was not increasing. While generally it is presumed that as the surface area of the material increases, then you anticipate an increase in uptake or adsorption capacity. But also what we observe is while the adsorption capacity was relatively constant, the adsorption rate, which is the kinetics, improved significantly with surface area. And so which tells us that while we are evaluating adsorbents, we need to have an equal weight on both the adsorption capacity and adsorption kinetics or rates as well. So next slide, please. So what we came to the conclusion is transforming a precursor material into a geopolymer does not necessarily guarantee that you'll have a high adsorbing material. And geopolymers in general, they have a negatively charged framework, which is balanced by the cations. And because the framework is negatively charged, they will generally perform poorly to uptake negatively charged molecules like the anionic dyes, for example. So to solve this, sometimes other researchers modify the geopolymer. For example, one article reports the use of CTAB to improve the textural properties of a metakaolin-based geopolymer. Others have addition of metal ions to improve the textural properties. But of course, these are good ways, but they also have the inherent limitations. For example, CTAB as an additive is generally expensive, and so it will increase the cost of preparation of the material. While using these metal ions as modifiers, you may also run the risk of desorption of the metal ions from the adsorbent to the solution, and so you may have secondary pollution while you are trying to solve a pollution problem in the first case. So the next slide, please. So what we wanted to do here is to see how we can improve the low surface area of geopolymer. And we noticed that we have just said that you can prepare the geopolymer either in an acidic or alkaline medium. Now we know that hydrogen peroxide decomposes quickly in an alkaline medium to generate oxygen and water. And so it is possible that we can have an alkaline activated geopolymer, and if we introduce hydrogen peroxide, then it will decompose to oxygen and water, and these can be entrapped in the geopolymer, and therefore this will improve the porosity and the textural properties of the geopolymer, while conserving the surface chemistry. Because, for example, if you use CTAB, you may improve the textural properties, but you'll be also changing the functionality of the molecule of the geopolymer, which may be useful in uptaking certain molecules and may not be useful in the uptake of other molecules. So we were also interested in preserving the surface chemistry of the geopolymer. Next slide, please. So as I've just said, the objective of the work was to improve the adsorption characteristics, and we are using pozzolan as the precursor material by modifying with hydrogen peroxide in an alkaline medium. Next slide. So in preparation, we used an alkaline activator solution made of sodium hydroxide, 12 molar, mixed with a sodium silicate solution with a liquid-to-liquid ratio of 2.4. Then this will be mixed with the precursor material, which is solid form, that is the pozzolan, with a liquid-solid ratio of 0.3. And then we introduced hydrogen peroxide at a ratio of 1% to the slurry material. And then this was then heated at 60 degrees centigrade for 24 hours. So we can have a quick look at some of the results. Pozzolan, which is a volcanic ash material, was characterized by XRF, and we are interested in looking at the alumina and the silica content, which are prerequisites for a good material for geopolymer development. And of course, you can see briefly there that silica around 47%, and then you have alumina around 15%. This generally tells us that this material was suitable enough for geopolymer development. Let's continue. In terms of the mineral phases, apart from XRF, we also performed an XRD analysis of the precursor and the geopolymers developed. And of course, most of the minerals that were present in the precursor were also present in the geopolymer, which means they do not really well dissolve in an alkaline medium. Let's continue with the next slide, please. In terms of textural properties, which we are really interested in, that is the surface area and the pore volume. We determined the surface area and pore volumes by use of nitrogen adsorption. And there is the plot, the adsorption-desorption plot. And of course, you can see that this type of curve, this is a type 4 curve, isotherm, and you can see the slope as from 0.4 P to P naught ratio, which tells you that the materials were generally mesoporous. And the red plot is the GP1 is the hydrogen peroxide plot, and then the black plot is the one that is unmodified. And you can see generally that actually the porosity of the hydrogen peroxide modified material was higher than the unmodified one. And in terms of the values, the next slide, please. In terms of the specific values, you can notice that the specific surface area increased from about 4.3 to 5.6 by introduction of just 1% hydrogen peroxide. That increase is about around 26% increase in surface area by introduction of 1% of hydrogen peroxide, while the pore volume also increased from about 6.0 to about 9.7%. So this generally tells us that the introduction of hydrogen peroxide, at least 1%, which is very low, will increase the surface area by around 26%, which is quite impressive. Let's continue. So we want to know, we can jump a surface morphology for the interest of time. So we will be interested to see what is the implication of these changes in the textural properties to the performance of the materials. And so we use the materials for the adsorption of methylene blue dye, which is a cationic dye. And you can basically see from the plot that the red one is the hydrogen peroxide modified geopolymer. It had generally a higher adsorption capacity over time. That is the effect of contact time and kinetics relative to the unmodified geopolymer. So in terms of what these rates really are, we will plot the same data to different kinetic models. And the next slide, please. And we used 3 kinetic models in their non-linear form because previous data research, we have shown that using the linear form of this equation either underestimates or overestimates the actual values. So you'll notice that generally in terms of kinetics, by the rate constant, the pseudo-second order model, you will notice that the hydrogen peroxide modified, that is GP1, had faster kinetics with a higher K2 constant. And that was also followed by a slightly higher equilibrium adsorption capacity of around 24 milligrams per gram relative to 19 for the unmodified geopolymer. The third kinetic model, that is the intraparticle, generally shows that intraparticle diffusion is not the actual rate determining step, and there are different mechanisms involved in the adsorption process. The next slide, please. So other than being interested in the kinetics, we are also interested in the adsorption capacity. which we can predict generally by isotherm modeling. And the data was fitted to 5 kinetic models, and it was generally best described by the SIPS model, which is a 3-parameter model. Our point of interest here, you can notice when you look at the SIPS model, Q max is the theoretical adsorption capacity, and you will notice that the GPO, that is the unmodified geopolymer, had a maximum capacity of 24.4 milligrams per gram. But with the introduction of 1% hydrogen peroxide, the adsorption capacity increased to 366 milligrams per gram, which that is almost 15 times higher by introduction of hydrogen peroxide. So this, in principle, is also consistent with an increase in the surface area, which we had already highlighted that the surface area has improved by around 26% increase in surface area. And this is followed by an increase in adsorption capacity by almost 15 times. And it's also accompanied by increase in the kinetics, the rate, which means the accessibility to the adsorption sites increased with the introduction of the hydrogen peroxide. Quickly, the next slide, please. Of course, the feasibility of an adsorption process is also examined in terms of the thermodynamics properties, that is the Gibbs free energy, enthalpy, and entropy. And of course, the negative delta G at all the temperatures examined indicate that the adsorption process was thermodynamically spontaneous. The positive delta H tells us that the process is endothermic. And in fact, the fact that the process is spontaneous and endothermic tells us that this process is governed by entropy. If we will relate delta G equals to delta H minus T delta S. So that means whatever controls this process, for it to be non-spontaneous, will be it will be entropically driven. The magnitude of delta H is less than 40 kilojoules per mole, and generally it is accepted that for reactions that have delta H greater than 40 kilojoules per mole, they are conceived to involve chemisorption mechanism. And so we can infer that the adsorption in this process was a physical process. The next slide, please. In terms of the possible adsorption mechanism, of course, we will look at the functional groups in the molecule being adsorbed and the functional groups present in the adsorbent and what are the possible interactions. There are several, of course, but electrostatic interactions were plausible because I've not presented the data here, but the adsorption was controlled largely by the pH and the geopolymer having a negative framework and the methylene blue being a cationic in solution, then we will anticipate that electrostatic interactions will play a significant role in the removal of the molecule from water. Next slide. So conclusion, number one, incorporation of 1% blowing agent, that is hydrogen peroxide, increased the surface area from 4 to 5, representing around 26% increase. That increase in surface area resulted also to an increase in the adsorption capacity by 15 orders of magnitude from about 24.4 milligrams per gram to 366, predicted from the SIPS model. Thermodynamically speaking, the adsorption of MB, that is methylene blue, was spontaneous, physical, and endothermic process. So we can generally conclude that the introduction of hydrogen peroxide enhances the performance of the pozzolan-based geopolymer for the removal of methylene blue from aqueous medium. And we published this work in the journal Silicon. Thank you for listening to me.
Thank you very much. I correct myself, Dr. Victor Shikuku, for your presentation. I now open the floor to questions and comments. Once again, if you cannot make any questions verbally, you can put it in the chat and I'll communicate the same to Dr. Shikuku. We have about maybe 3 minutes of questions, comments, and then we shall proceed. So as I can start, Dr. Shikuku, maybe I can ask, one of the themes that has really been part of this conference is the theme of CECs, which is pollutants of emerging concern. And with geopolymers, maybe I can just ask, is there a possibility of adjusting geopolymers to be able to absorb these pollutants such as the APIs, pesticides, and the like? Thank you.
Thank you. Yes, as you put it, we have emerging contaminants, pharmaceuticals, and illicit drugs, and so forth. And yes, geopolymers, of course, very little has been done as far as geopolymers performance with emerging contaminants. But from the data that we have reasons to believe that they should perform generally well, even with these chemicals of emerging concern. Though in terms of empirical data, very limited data has been done for the performance of the geopolymers for uptake of the emerging contaminants.
Okay, thank you. I can for your response. Are there any other questions from the floor? One more minute. Oh, and maybe let me ask one more, because the reverse is also true. As we create new substances, now we have to really think about, is it potential to create CECs? So for these geopolymers, do they have that potential to introduce more problems to our environment, like the others that we have seen throughout this conference? Thank you.
Yeah, that is a good question. When we characterize the material in the XRF, you will notice that in that table, elements like lead and their oxides were below the detection limit, which is very important, such that the absence of these toxic heavy metals in the precursor material was a plus. Number two, the geopolymers also solve the problem of secondary pollution, because the geopolymers themselves are like cement. So what it does is it immobilizes the toxic heavy metals and other pollutants that may be present in a precursor material. So when you take the precursor and you develop a geopolymer, you are basically actually immobilizing. It's like you are fixing them in a concrete kind of material. And one of the uses of geopolymer is immobilizing toxic metals, even radioactive metals. When you're disposing them, geopolymerization is one of the techniques. And so that is one advantage of the geopolymers in terms of preventing secondary pollution. And then the spent material, after you have used it, the geopolymer itself has other applications. So it can be used in construction industry, for example. So that means that even the spent adsorbent is not a waste material. Unlike, for example, when you talk about our water treatment processes, you will have production of a lot of waste sludge, which if you use, for example, in agricultural land, then you are transferring pollution as well to the landforms. So the geopolymers are advantageous in also that sense, that even the spent material is not a waste material, it is still productive, and the geopolymer itself helps in controlling or immobilizing the different wastes that may be present in the precursor material.
Okay, thank you. I can see one question from Dr. Enos Wambu. Daktari, please proceed. Dr. Wambu, I can see your hand is raised. Kindly make your comment or ask your question.
Sorry for that. You get me?
Yes, we can hear you. Proceed.
Yes, sorry, I was talking to myself. I'm just saying very grateful to Dr. Shikuku for that presentation. And I really like the kind of data that he has been able to obtain on those material. I just wanted to find out, I saw that he has 5 isotherms. What informed him to use so many isotherms? What specific particular parameters did he want to obtain with each of the 5?
Okay, thank you. First of all, we used the different isotherms give us different information depending on the theory behind the isotherm. One, there are like Stips and Langmuir isotherms, where our interest was in predicting the absorption capacity, because both of those isotherms have a Qmax. And then the DRK isotherm will also give us insight on the energies that are involved in the adsorption process, while the constants of the different isotherms also can give us insight on the type of adsorption, whether it is monolayer, heterogeneous nature, or homogeneous nature of the absorbing surface. So the different isotherms will have given us insight on what could be happening in the absorption process. And so that is why we will have chosen both 2-parameter and 3-parameter isotherm.
Okay, thank you, Dr. Shikuku. I think from the chat, I've just seen appreciations from the attendees on your presentation. So I want to appreciate the presentation you've made. And we'll now proceed to our last presenter, which is Mr. James Koskei, who is a PhD student in the Department of Chemistry and Biochemistry, University of Eldoret. So his presentation is titled Extraction of Metabolites of Stem Bark from Acacia macrothysa and Screening for Ascorbic Acid and Total Antioxidant Capacity. Mr. Koskei, are you there? So just give us a couple minutes to maybe you reach out to him. Just give me a second. So members, just give us a few moments. We want to just see if it's a technical issue. So maybe wait for until about 4:38, and then I'll communicate again at that point. Thank you.
Hello? Are you listening? Are you hearing me?
Sorry.
carrying out antibacterial bioassays. Was carried by the presentation is pharmacological compounds from stem barks from Acacia macrothiza, identification and screening for antimicrobial activity. So my co-authors are Professor Lusweti Kitui, Pius Kipkemboi, and Stephen Barasa. Next slide. Next slide. So the Acacia macrothiza is has ethnopharmacological properties, but it is endangered and attacked by herbivory. There are goats, cows, sheep graze on, and also because of cultivation for cash crops, for commercial cash crops like maize, wheat, and potatoes. So there has been it has been endangered, and it is becoming a rare species. So stem barks from acacia were sampled in 3 years, 6 years, and 15 years from Moiben, and they were extracted with 5 solvents and an alkali solution. So the phytochemical screening tests on 2 gram positive and 2 gram negative showed that the ethanol extract had a minimum inhibition concentration of 6 milligrams per ml, and they were active on subtilis, Bacillus subtilis. Next slide. The content in stem of the bags of the ascorbic acid was 4.8%. The total phenolic acid was 24.44%. That was the maximum. The total flavonoids was 1.25 to 2.5%. And we also carried out total antioxidant capacity, which we used an ascorbic acid standard, which had 23 milligrams to 48 milligrams per gram of dry weight of the extract. So the total antioxidant capacity was less by 1.25 to 4.25 milligrams, less than the ascorbic acid standard. So the isolation and extraction using hexane, methanol, dichloromethane in 50, 20, 30 ratios of solvent mixtures, we afforded about 6 to 7 fractions, which we identified to contain phenolic acids and flavonoids. These were the most likely compounds that were responsible for antimicrobial activity. Next slide. So the acetone extract had a minimum inhibition concentration of 6 milligrams per ml, and they were active on Bacillus subtilis. The methanol extract minimum inhibition concentration was 6 milligrams per ml, active on Bacillus subtilis and S. aureus. All tests were against standard gentamicin antibiotic, which had a minimum inhibition concentration of 0.05 milligrams per ml. So this means that the minimum inhibition concentration of 6 milligrams was far much less than for the standard 0.05 milligrams per ml. So they were less active than the gentamicin antibiotic, which is a gram-positive antibiotic. So next slide. So uses of plants have been, we have a history of uses of plants since time immemorial, from the ancient Egyptian civilization, the Indian medical system, the Ayurveda. Also in the Middle East, the Assyrians recorded the plants for medical prescriptions, like Hippocrates. Like Hippocrates at 4060 to 377 BC prescribes about 300 medications for, next slide. Next slide, please. Next slide. Naomi, are you listening? So there have been reports on isolation of flavonoids and polyphenols using HPLC, DAD, AB, TZ chromatograms of Acacia famicuflua methanol extract, and which were detected at 280 nanometers using a reversed phase chromatogram for by radical scavenging activity detected at 414 nanometers. And you can see that we have in the figure 4.2, we have identified polyphenols running from retention times to 280 nanometers. And using the radical scavenging LBTZ, which detected at 414 nanometers. Next slide. So the chromatograms of A, B, and I, doratoxyxylon B, and A implexa, A pectinata, and Acacia famicuflua methanol extracts compounds were identified as apigenin, naringenin, phenolic acids, gallocatechin, catechin procyanidin dimers, and epicatechin, and also rutin and luteolin. Next slide. So Acacia farnesiana is one of the plant of the same family, and recent studies have shown that the extracts are active on M. roseus, S. aureus, and Bacillus cereus, E. coli, and P. aeruginosa. So these extracts have active bioactivity on fungal species like Candida tropicalis, S. aureus, and K. pneumoniae, which were resistant to, next slide, to Streptococcus viridans, Staphylococcus aureus, E. coli, Bacillus subtilis, Shigella, Sondre, using agar diffusion method. So there is highest activity against 3 bacterial species, E. coli, S. aureus, and Salmonella typhi. So another plant is A. nilotica extracts, which have activity on 2 fungal strains, Candida albicans and Aspergillus. A. nilotica is also used in tanning and dyeing of leather, and is as important processing is one of the important processing know-how. A. nilotica also has next slide. Next slide, please. Aphrodisiac properties. So in my methodology, I used 4 solvents: 70% ethanol, 200 ml, 70% methanol, 200 ml, acetone, 200 ml, which extracted 90.5 grams in 200 ml extraction flask by warming. These were left overnight and then filtered and water evaporated to get crude extracts. These crude extracts were kept under 15 degrees centigrade to be used for screening, phytochemical screening on the 2 gram positive and 2 gram negative organisms. And then the rest was used for the dichloromethane extract was used to isolate the flavonoid fractions. Next slide. Next slide. Next slide. So the quantification of the back of the stem were maximum 3.915 milligrams per ml dry weight of total flavonoids. And then in the age 2 6 years old, Acacia microtiza. And we had 1.028 milligrams per gram dry weight and 2.129 milligrams per gram of the dry weight in 6 and 15-year-old plants. Next slide. So the Shinoda reduction test was used to identify the flavonoids. And also we carried out a calibration curve using the ascorbic acid standard, which was linear at 0.0 to 4.45 milligrams per ml of the acetic acid equivalent. So there was high concentration, maximum 24.44% of total phenolic acids, and a maximum 2.5% of total flavonoids. So the quantification of these secondary metabolites were above in the bags age 3 years, 6 years, and 15 years. Next slide. So the flavonoids showed UV absorption spectrum, which occurred at 700 nanometers in the UV visible region. Next slide. So you can see the UV visible spectrum fraction of one of the fractions of 1 to 7 of Acacia macrothiza, and you can see that there is a maximum at 425, there is at 675 and 700. Next slide. Next slide. So next slide. Next slide, please. So also this were I carried out a synthesis of one of the flavonoids, and I carried out the IR spectra, and you can see that we have the carbonyl absorptions, the CH absorptions, and the carbonyl absorption at 17,000 reciprocal centimeters. Next slide.
So you, Mr. Koske, you have 2 more minutes. Please summarize.
Yeah, during the synthesis, next slide. You can see that the synthesis of 2E13 diphenylpropene 2-in-1 1-on is we use alkali, which abstracts a proton here, and then what happens is that we create a negative nucleophile which attacks the carbonyl of the acetophenone, and then what we get is there is a dispersal of charges, and when this comes back abstraction of hydrogen, we get the compound 1,3-diphenylpropene 1 standard. So next slide. So this is one of the NMR absorption of the standard, and you can see that the last one here is the carbonyl absorption, carbonyl proton, and then acids here which are phenyl. There is 2, then 2 star, this which are located at around 7 to around 8 ppm. Next slide. So there is a comparison of carbon-13 chemical shift of trans-chromine and diphenylchromine, and this you can see that there is the 1 proton, we have 5.8 ppm, and then the other protons go 6.95, and then the carbonyl. Next slide. So you can see that there is a difference between the trans and cis. This is trans hydrogen. So there is absorptions are different for trans and cis. Next slide. So the antifungal and bacterial activity of the extract is shown here. You see that dichloromethane, acetone, then there is gentamicin standard is 6 for 0.05 micrograms. The others are in 6 milligrams per ml. So you can see that the standard is highly active, it's micrograms, but the other one is milligrams per. So these are less. The dichloromethane acetone extracts have less minimum inhibition concentration than the standard gentamicin. So next slide. So also the ethanol, methanol, so these are the values which are for the concentration. So this is gentamicin 0.05 micrograms per ml, while for methanol is 7.1 milligrams per ml. Next slide. So this is all tests against the standard gentamicin were for the gram-positive antibiotic. So they are almost nearly all 6 milligrams to 7, the maximum was 7 milligrams, and all these were less than the gentamicin standards. So that we conclude that it is not more active than our antibiotics, which are conventional antibiotics. Next slide. Next slide. Next slide, please. So the flavonoids and total phenolic acids in Acacia microta show are the most likely compounds that are active on gram-positive and gram-negative bacteria. So these chemicals used in control of fungi and bacteria cause many side effects. And plant origin antibacterials, antifungals are safer than synthetic drugs. So they have no adverse effects on the body systems. So S. aureus and E. coli are the most susceptible organisms. And we recommended that the use of bioassay guided isolation, which are far much better than the solvents extraction, and then you proceed to carry out the bioassays. Next slide. So I acknowledge the MKU pharmacy department for assisting me to carry out the microbial test. University of Eldoret Research and Innovation for award of the graduate research grant that led to the success of the Acacia research project. Thank you.
Thank you very much, Mr. Koskei, for the presentation. I'll now open the floor for maybe 3 or 4 minutes of questions and comments from the attendees of this session. I can start first with a comment on your presentation. You did some really good work, and there are a lot of really good information that you presented. Unfortunately, your presentation did not do justice to the work that you did. So in future, spend a bit more time to really put your presentation well together so that there is a good flow and we can really see the data coming out. The work is good, but the presentation wasn't done so well. So maybe improve on that for future presentations. So I'll open the floor to anyone who has questions. Kindly, the floor is yours. I will also check the chat for anyone who would like to post there instead. Yes, I can hear you. Professor, Mr. Kemei, do you have a question?
Yes, thank you, Mr.
Please
Koskei,
proceed.
Yeah, thank you, Mr. Koskei, for your presentation. I just wanted to know the difference. You said in your recommendation that the use of bioassay guided isolation for flavonoids is better than solvent extraction. What's the difference? Because to me, they are the same. It's only that you actually do solvent extraction as you do the bioassay.
Yeah. So I think they're almost. I think I meant culture. Culture. I recommended the use of things like root culture, which we can get more compounds from of certain particular compounds from a plant, a part of plant, root culture.
Okay.
Bioassays. Yeah.
So maybe I can ask, what was your, two questions. Number one, what was the reason why you chose the acacia bark instead from all the other parts of the tree that you could have investigated? Why did you select the bark? And number two, you used the Staph aureus and E. coli. Why did you select these two bacteria among all the others that you could have investigated? Thank you.
Yeah, this from the communities, which local communities, most of these plant extracts from the bark are used to treat the conditions of the stomach and the bowels, of which most people don't have piped water, and the most diseases that they have fungal and bacterial infections, and most of these extracts are used and they're active by the locals without even having prescriptions on the decoction. So this is what I was interested because some of these extracts, sometimes they are poisonous and they need to be quantified for safety, efficacy, and efficiency by even quantifying the quantity of phenolic acid in a particular decoction, so that it can serve as administration for administration purposes to avoid the poison.
Okay, thank you. Are there any more questions from the floor? So there seems to be no more questions. So I'd like to say thank you to Mr. Koskei. So we've come to the end of the session. I'd like to say thank you very much to our 4 presenters who were able to present their work, and also to appreciate all of those who also attended and helped to critique their work and to give comments and provide questions to help our presenters further improve on what they've done. So we are going to come to a close. I'll first give us a rundown of what is expected for tomorrow's session, which is our last day of the conference. And once I'm done, I will invite Ms. Caroline Koskei, who will pray for us, and that will end the session. So for tomorrow, we have day 3 of the conference. So the rundown is that we will have registration from 8 o'clock to 8:50 a.m. And then after that, we will have a prayer and the beginning of the parallel sessions between 9 and 10 a.m. So if you are to present in the morning, or if you have colleagues who are to present in the morning, please make sure they are aware of that. Then after that, we will have our 6th keynote speech from 10 o'clock by Professor Rajarashwara Achur, who is one of our collaborators from India, who will make his presentation. Then after that, we'll have a plenary session following his keynote address. Then we'll have a short health break. After that, we'll have our 7th and final keynote address, which is from Dr. Vivian Tuwei, who is one of our own, a lecturer of biochemistry at the University of Eldoret, who will give the final keynote address. 6th and 7th, we had planned for 6, but we had the great opportunity of having our Vice Chancellor, Dr. Akenga, Professor Akenga, giving a keynote address. Then in the afternoon, after Dr. Tuwei's keynote address, we'll have a plenary session that will end at 12:40. Then after that, we will have the closing ceremony that will start at 12:40 and end at 1:30. Then we'll release everyone to go for lunch. So we expected to end at 1:30 p.m. So please note that for tomorrow, and we hope you will also join us tomorrow for that session. I'd now like to invite Caroline to make the final prayer as we close the session. Thank you.
Okay, thank you, Dr. Bisem. May we bow down for a word of prayer. Thank you, Lord, for this wonderful day that you have given unto us. Indeed, we've seen your faithfulness since the start of the conference up to now. We are very much grateful for your goodness and grace upon the organizing committee who have worked tirelessly to see that this conference has been a success. We want to thank you also for every presenter and every keynote speaker that have spared their time to share the knowledge in this forum. How we pray that, Lord, this will not be the end, but you shall always provide for us other opportunities that we may also learn from one another. We want to thank you also for everyone. I don't want to forget everyone who have participated in one way or another, including our university management headed by our VC. We want to pray that as we part now, may you be with us as we look forward for tomorrow. We pray we are looking forward for your blessings and we are looking forward for your guidance and faithfulness. We pray this short prayer, believing and trusting in Jesus' name. Amen.
So I call this session to a close. You may leave at your own pleasure. Have a lovely evening.